Okay, so let's start. Hello, everyone, and welcome to Transhuman Race the Symposium. First, I want to mention how grateful we are to see so many people interested in the symposium, and thank you for being here. It's Team Heart's first big event, so we are really excited about it. And my name is Mariia, and I will host today's event together with Victor here.
Hello.
Uh, as I said, this symposium is really important to us, and with it, we want to raise awareness about the topics of human augmentation and transhumanism in the Netherlands and all around the world. So, today, all of us will dive into the concepts of transhumanism and show you how this philosophy can be put into practice. Uh, Now, let me tell you a little bit about the schedule. First, we're going to have three speakers give their presentations. So now Victor and I are speaking, and after we are done talking, you will hear about winning the transhuman race from Anders Sandberg and about transhumanist technologies from Peter Joosten. And after this talks, we are going to have 15-minute break during which we'll have some nice activities. I'll explain later a bit more about them. And after that break, we're going to have three more presentations during which you will learn about technologies for understanding and preparing the brain from Ed Boyden, about organic neuromorphic devices from Yoeri van der Burgt, and about sculpting the evolution of biology and technology from Kevin Esvelt. And then again, after the talks, we're going to have a 15-minute break, again with activities. Um, so after the talks, we are going to engage in a discussion about human augmentation and ethics with other speakers, and you will get to be an active participant. After the panel, we're going to say some final words, and that would be it. Now I want to tell you a little bit more about the activities. So, after each talk, you will get an opportunity to ask questions to the speaker. There will be like a 5 minute window where we're going to take questions from the audience. If you watching the live stream from the YouTube, you can put your questions to the chat and we will read this chat. And during the panel discussion, we will constantly keep an eye on the chat. So it will be like we are talking with you. So please keep in mind that this event is recorded. And if you ask a question, your name will appear on the screen. And we feel like the big disadvantage of such online events is that you don't get to interact with fellow participants. And to combat this, at least to try to, we created 3 Google Meet networking rooms that you can join and where you can meet and interact with fellow participants and transhumanism enthusiasts. And some members of HART will always be there to keep you company. So to access the rooms, go to teamheart.nl/room and then enter your preferred room number. And here is the most fun part, at least in my opinion. To keep you active and engaged, we'll run a bingo competition. Hopefully you know what it is, but for those who don't, so you get a list of 16 things to cross off. An example of what you can see there is a card that says, heard the word example. So when you do hear the word example, you get to cross the card off. And when you cross all 16 of them off, you're done. And we'll give 2 prizes, exclusive prizes for the best players, which we will evaluate based on how fast you complete your bingos and how many of those you complete. So to generate your unique card, go to teamheart.nl/bingo. During the breaks, you can just get off the screen and make something nice for yourself, like a drink or something. And you can also participate in the small activities we've prepared. We are going to use a special platform for this, and to get you acquainted with how it will work, let's just try it out right now. Please, all of you, go to teamheart.nl/break and answer the question that pops up. So I am now going to put the AHA slide. Okay, so let's give it a few seconds to see what
Yeah,
you...
there are people popping in.
Yeah, okay. So most of you are somewhat familiar or moderately familiar with human
Actually,
with
do this at the end of the
transhumanism.
evening again to check if it changed.
I don't think you can answer it again. Okay, so let's do another 20 seconds, let's say. Doesn't change that much. Okay.
Where would you be actually, Maria, on this?
I think I would be moderately familiar. It's pretty hard to be extremely familiar.
That's a good point. I'm curious as to the people who are.
Yeah, that's probably some of our speakers today.
Yeah, that makes sense.
Okay, so most of the people are somewhat familiar, and the second most popular option is not at all familiar. So I suppose it's great to have you here because after this event, hopefully your answer will be different. So let's go back to the presentation. Um, so yeah, this kind of activity we are going to have in the break. And all the links that I just showed you can be found on our website, where the arrow is here pointing on the right. And you can also see all the links in the Eventbrite confirmation email and the live stream description right on YouTube. Anyway, this is probably all you have to know about the symposium. Really hope you enjoy it. And now I will give the word to Victor, and he will tell you a little more about Team Heart.
Yeah, exactly. So, as Maria already said, we are Team HART, and we're a very new student team that is funded by the Eindhoven University of Technology. And let me just briefly explain what we focus on. And maybe it's easiest to just do that by asking, well, why did we come together in the first place? And that is because all of us in the team are fascinated by a single question. And that is, are we really stuck with the senses we're born with? And we think we don't necessarily have to be. We like to illustrate this by the connection between parrots and pirates. You all know that these two are connected somehow, but what you may not know is that there was an actual reason why pirates carried parrots along their travels. And the reason is that a parrot is sensitive to changes in barometric pressure in the environment. And you can imagine that this is a very nice predictor for rainstorms, which is why they're extremely useful. But also, a thing that we are wondering specifically is, well, why can't human beings sense this? And that's the thing we're focusing on. Well, to look about that, let's first think about what our brain is doing. And I'd already like to apologize to potential neuroscientists here. I'm just a physicist. I will grossly oversimplify this. So basically, the brain is just receiving electrochemical signals from your senses, for instance, your skin or your ears or your eyes, according to a certain pattern. But this is everything the brain ever receives. And somehow, this complex interplay of all these signals, your brain transforms into the world that you see right now. So, right, everything you hear, see, feel, smell, and taste right now is just an electrochemical signal for the brain. Um, okay, but what if we now take a slightly different approach? Let's say normally you would receive sound via your ears, but what if you're hearing impaired, for instance? Could we take sound and turn sound into a vibration on your skin? And if we do this according to a consistent pattern, could the brain learn to recognize these electrochemical signals again, so long as they arrive according to a certain pattern over and over and over? Well, that is what we're currently testing. And the way we do this is with what you see on the screen. This is a sleeve with 24 vibrational motors. And it's our very first prototype. This was, I think, maybe even on the day that we got it working. So there's some emotional attachment to this image. And we are currently working on the second and third iterations of this already. Now, what does this thing do? Basically, it takes a word and it chops it up in phonemes. If you take the word every, that would be every, as three different phonemes. And then every phoneme is a distinct vibration that you can feel on your arm. And one of the members of our team, Robbe, trained 10 different phonemes. So he learned to recognize 10 different of these vibrations with which you can construct words. And afterwards, he was able to learn to recognize 10 words just by feeling in only 5 minutes. And now that single application is very cool, we think anyway, but we don't necessarily intend to stop there. What we envision would be to create a sort of app store for your body where you could create and download new or even improved senses. So we've already sort of touched on the hearing impaired. You could improve hearing or maybe even enable instant translation. But you could also think about creating 360-degree vision or becoming sensitive to your internal health. Or maybe you want to be a modern day pirate, have your own parrot, but then on your own arm. So if we could sense barometric pressure this way, we could make that possible. So to briefly summarize that, the aim of our team is to make the world more inclusive while we make humans more exclusive. And the final goal would be to reach a state of being more than human. Now, you can imagine that this is just a very tiny fraction of everything we can do with transhumanism. And that is part of the reason, of course, why we host a symposium like this. Now, we are working in a very tiny fraction, and there's no better person to expand on this, to give you a better overview, than Anders Sandberg, who's the first speaker of today. So if we could switch to the, yeah, there we see him already through the
Hello.
detailed overview. So Anders Sandberg is a senior research fellow at the Future of Humanity Institute at the University of Oxford. He has long been an active participant in the debate on human enhancement, transhumanism, global risks, and the long-term future of humanity. And the topic of your talk, Anders, will be on winning the transhuman race. And we're very much looking forward to it.
Thank you very much for having me here. And it's delightful, since I'm a bit of a philosopher, that you titled this whole thing kind of the transhuman race, because that's a challenge. You immediately start wondering, what do you mean by that? And then, of course, as a philosopher, I immediately have very fun trying to figure out what to say. So my little talk is going to be about what could that possibly mean? So let's see if I can get sharing to work here. I'm originally a computational neuroscientist, and then I ended up in the philosophy department of the University of Oxford because I was working on the ethics of human enhancement. And that is, of course, a fantastic place when trying to think about meanings of words and meanings of how we change as a species. So the word race has a bit of a double meaning in English. So it's kind of built in because it actually comes from totally different sources. One is from the Old Norse ras, which means rapid forward movement, which leads to this idea of a contest of speed. Indeed, at least in Scandinavian language, we have a lot of words that seems to connote speed linked to ras. But then we have the Italian razza, which is a bit uncertain where it's actually coming from, which now have turned into major groupings of humankind, but originally might have some complicated link to the Latin radix, a root. So we have these two very different sources of the word race. One is where we're rooted, what kind of beings we are, and we might speak about the family resemblance. Another one is this moving forward, this race that might be competitive, or it might be that we're all just together trying to get forward in a great, nice, happy running event. So I think this leads to these core questions that we're going to be discussing tonight. Towards what are we moving? And are we doing it together, separately, in competition, or maybe something completely different? So when you start talking about transhumanism, you usually better give some kind of definition. And the traditional idea of humanism is that we can improve on the human condition. So this came about during the Renaissance when people started picking up on classical ideas and then moving them forward to the Enlightenment with this concept that maybe through rational thinking, education, a bit of science, we can avoid starving. We can avoid having much material trouble. We can become nicer people through education. And that has, of course, continued in the humanistic tradition in various branches. Transhumanism takes this a step further. It questions the human condition, including the biological human condition, and asks, how do we make this better? So this could include things like downsides of human life, like aging and pain. Do we really need to age? Do we really need pain? In the case of pain, we know that pain is a rather important signal that tells us that our bodies are in danger. But quite often we receive that signal and then it just keeps on going. We already know that we need to go to the doctor. We already know that a part of the body is damaged, but the surgeon has fixed it. And yet retaining the pain now is just causing suffering. At that point, we can intervene, of course, with anesthesia or painkillers or other tools. Similarly, aging. Is it really a law of nature that organisms age? Well, it turns out that there are organisms out in nature that don't show any form of aging whatsoever. And it seems like in the lab we can manipulate the aging process. That, of course, leads to interesting questions like, could we remove aging? And would it be a good idea? And in general, of course, in the past, human evolution just happened through the ruthless selection of the environment. But gradually we made it much more subject to our own, sometimes more humane goals. It's not just that we try to remove pain. It's also that we realize that many illnesses and other problems, we can actually find solutions to them. And we might now be on the threshold of being able to modify our bodies and minds directly. And this would enable entirely new forms of evolution that is not found in nature, but subject to human values. Which of course also mean that now we better think about what kind of values we should try to apply. The problem is, of course, now we're getting into the deep waters of philosophy here. And this is really the answer to the towards what are we moving question. Now, there are some people that say that there is a human essence that we must not tamper with. And others would say, look, we have individual liberty. I have a right to my life. I have a right to my body. I have a right to freedom. I have a right to modify my body as I see fit. Others would say, yeah, but some of these changes might be disruptive for other people. So we actually need to think about the interactions with other people who might not be enhancing themselves. Consequentialism in ethics asks what changes would improve well-being and the chances of future generations. But also another interesting possibility, there might be entirely new forms of value that we might want to search and strive for. We could imagine some monkeys in the past thinking about evolving into post-monkeys. Would that be good? And they argue that, yeah, if you're smart, you can get a lot of bananas. So we should become post-monkeys because we get a lot of bananas. We, as post monkeys, are very good at getting bananas, but we also have discovered that there are art, science, philosophy, religion, sports, things that the monkeys can't even conceive of. And it might very well be that if we become post human, there are new forms of value that are beyond the kinds of value we currently enjoy. And yes, the post humans might also enjoy the bananas and art and science, but they might have these post values that they might say are even more important. On the other hand, there are very pragmatic concerns about safety. After all, many of these technologies are not going to work well on the first try or even on the 10th try. Some of them are going to have interesting emergent drawbacks. There might be really important issues here about continuity. If we change ourselves too much, maybe we lose who we are. And this might both be individually. If I upgrade my appearance a little bit, that might not change me. But what if I upgrade my personality? At some point, it might no longer be Anders, but somebody else. And the question is, should I care? Most people care quite a bit about that. Similarly, we do care about the continuity of our species. You could imagine a dramatic upgrade that we became something very different. And if it's too sharp, too rapid, we might say, that's just replacing humanity with something alien. Maybe something very nice alien, but it's still an end to humanity. We want some aspects of ourselves to continue into the future. There are also important issues that sometimes some enhancements might be in conflict with other people's values. We can see that, for example, in the current debate about gender identity and transsexuals, where some people think that it's very important that humanity should only have two sexes. And others would say, well, let's have as many sexes and genders and identities as we want to. Let's make this totally free. And that makes the first group very disturbed. And they would argue that we're actually harmed by the existence of these weird new genders. While the second group would say, yeah, but you don't have a right to interfere with our bodily freedom. And that, of course, leads to a key question, which I hope we will be able to deal with a bit more. How do we go about this? So do we have a duty to remain together, or is it that we should cherish diversity? There might be, for example, a risk of splitting into factions that don't get along. On the other hand, we also reduce risk by having a diverse set of people and ways of solving things. Many forms of transhumanism and posthumanism in literature have been arguing also about whether it's a single goal, a good direction that we should all be aiming at, or whether it's actually a vast radiation in different directions. Many critics would say, look, transhumanism is just going to unify us and make us all similar, and the end result is going to be this homogeneous, boring species. That's a bad thing, so we should resist it. While many transhumanists I know instead say, no, we should individually become radically different and test out different and new possibilities, which I think is great, except that we now have a problem that we might need to get very diverse systems to work together. There is also an important tension between improving things right now for existing people or maximize the long term. It might be that speeding up certain technologies might help us who live right now, but might induce risks because we're getting powerful technology early before we know how to handle it safely. But if we delay, we are going to be much more cautious and useful. But unfortunately, we who currently live are not going to benefit it. So very important issues here about how to handle disagreements about what it means to be a human. We might want various forms of hedging where people who disagree can still make deals. And very interesting issues here about where we want to go. I think my own modest view is that what it's all about is aiming for an open future for humanity and for individuals. Transhumanism can be on the individual level. I might want to have new senses. I want to see ultraviolet light. But it might also be about our societies. I want to live in a society that's sustainable over millennia and millions of years and can go to space. But there might even be on a cosmical scale that we might say we're representatives of life, intelligence, and consciousness. And maybe we even have a duty to spread that to all the unliving matter out there. Now, we don't know really in philosophy what is the right answer here, but it's very clear that we should avoid premature closure, whether that is that killing ourselves in an unwise experiment or existential threats to our species. We want to have a freedom to choose this diversity. And there is a lot of value in exploration. I think right now our society is a little bit too cautious about exploration. We need a bit more bold exploration, even if that sometimes means that we burn ourselves and realize, let's not go there then again. And I also think we need to be much more long-termist. It's not just about the next few years or next few decades. We literally can affect the future billions of years in the future if we play our cards right. We can create a wonderful, grand future together. And I'm hoping this meeting is going to help us start with these ideas. Thank you.
Thank you very much, Anders. It was very, I think, a great introduction with some very important questions that would be indeed great if we could tackle tonight.
You might notice that as a philosopher, I'm giving more questions than I'm answering it.
I suppose that will always be the conundrum. But maybe I can try to get you to answer a question from our side in that case. Is especially from our point of view as students right now, how do you think we should deal with different ideas or maybe values for the future? And specifically, should we invest in specific kinds of research? Should some research be preferred over other research, or should everything be treated equally in that sense? What's your take on this?
I think it's very important to set priorities right. And now I must admit, I'm bad at that personally, but I still know that it's important. And the reason is that if you have a bunch of different problems, like technologies or issues you want to solve, how important they are is kind of random. But typically, it has a very skewed distribution. Quite often, something like a heavy-tailed distribution or a power law, which means that the most important thing is probably an order of magnitude more important than the second most important thing. And that means that if you have a lot of options, you should try to figure out to put them in the right order. If you do that in the wrong way, you might lose most of the value you could have gained. So that suggests that getting the priorities in order is actually way more important than we normally think. Normally, we say we should think things through a little bit beforehand, and that's it. But I argue that we should actually spend a lot of time thinking things through, but also be aware that we are going to not know everything. It's going to be wrong from time to time. We are going to need to update those priorities. So generally, I think you can find tricks and heuristics like is the effects of this enormous? That's kind of a good sign. Is it something that people have neglected so we know much less than we should about it? Is it also tractable? Could I actually do something useful about it? This is something that people in the effective altruism movement are using for guiding where they want to put in charity, but it works well also for research projects or even what to study. And another thing is you can change the ordering of when things arrive. There are some technologies that we might want to have early rather than late, especially technologies that make other technologies safe. So you want to have seat belts as quickly as you have cars. When you develop geoengineering, you probably want a way of undoing that at about the same time or earlier when you get geoengineering. If you develop advanced artificial intelligence, you probably want safety measures to be in place before it gets really powerful. And the cool thing is accelerating the certain technologies is much easier than stopping other technologies. It's kind of more exciting to figure it out too.
Great, great. I think that's a very nice perspective to take into consideration. I also see some questions that have appeared in the chat. And yeah, it's a question from G. Stolyarov. Sorry for probably
Gennady
butchering your
Stelerov.
name. Thank you. And the question is, no matter how great the diversity among humans or other sapient beings, do you think we can all converge upon the same core values, for instance, survival and longevity, in the transhumanist framework?
It's a great question, and unfortunately, it's one of those big questions in meta ethics that philosophers can build entire careers on. And unfortunately, we don't know yet. So there are some philosophers who would argue that actually, yeah, ethics is something we make up. There is no reason why it should converge. And others would say, no, actually, there are probably optima. You can even make an argument that regardless of what your goals are, there are certain things that are generally effective for reaching them. So for most goals, surviving is a good thing. There are a few weird goals that means that survival is not relevant, but most goals for most people and most beings are going to be pro survival. Longevity is generally good for achieving your goals. So I think at the very least we can make the claim that there are some things we can mostly agree on. Then we're going to maybe disagree on the big goals. And it might be that philosophers a million years from now are still writing papers and are still not figuring it out. But that's something we can find out. If we survive long enough, we have the time.
Mhm, mhm. So that's a crucial element there, being there long enough. In that fashion, I think there's a very nice next question. Maybe looking at the time, that will be the last question we can take. And the question is from Lulu Farrell. Is there any development right now that scares you?
Yeah, there is a fair bit of biotechnology that makes me nervous. It's awesome in its own way. I really admire the technological skill going in and the amazing things. It's just that I can see a few really bad uses of that. And what really annoys me is that I don't even want to talk too much about them, which of course makes it sound like either I don't know what I'm thinking about, or maybe I'm just trying to sound ominous and mysterious. It actually hampers the ability to do something useful about these risks. So generally, I think I'm less afraid of things exploding as stuff that replicates. And nanomachines and computer viruses are actually much worse at replication than biology. Biology comes with replication built in. That's what it's for. And it's also very robust. So that's why biology is awesome and scary. And I think this leads to an interesting question as a student. How do you want to work in order to be an ethical student? I know some people who said, okay, I'm not going to work on certain areas because they think that's going to have military applications. There are other people saying, I should be working on those areas because I might actually have a say in how it's applied. And others would say, actually, maybe I should become a diplomat instead, so those military applications don't get to be used.
Okay, those are some perfect thoughts to take later with us into the panel discussion. Anders, thank you very much for your
Thank you.
contributions thus far, and we'd love to see you at the end of the evening at the panel discussion again. Thank you.
Thank you.
And with that being said, I'd like to announce the next speaker, who is Peter Joosten. He's a biohacker and a cyborg futurist who investigates the impact of biohacking, human enhancement, and transhumanism in his keynotes, articles, and on his YouTube channel. And he's also the curator of the platform Superhuman Talks, where he writes and interviews experts about the coming era of upgraded humans. And his talk will focus on transhumanist technologies with the question, can we transcend mankind? Peter,
Hi,
good to
Peter.
see you, and
Thank you.
forward to your talk very much.
Thank you, Mariia and Victor, for inviting me. There's my presentation. Awesome. I actually want to start with a little story. It's the year 2050, and Special Agent J.C. Denton is standing next to the Statue of Liberty in New York. And he's there because underneath, in the bunker of the Statue of Liberty, there are terrorists. And the terrorists, they spread the deadly virus, great death, all over the world. Well, I am playing the character J.C. Denton in a computer game called Deus Ex. And it's the year 2000 and I'm still in middle school. And I really love this game, not only because of the gameplay and the story, which kind of resembles the answer Anders gave to the last question, and also a conspiracy theory concerning COVID, but especially because you have human augmentation in this game. So you can buy special hands, maybe, just like HART is developing, so you can steadily aim, and you have bionic legs and special eyes with information on your display. And I really love the game. And now, more than 20 years later, actually, I'm not a J.C. Denton. I'm not a special agent, but I'm a biohacker and a cyborg futurist. So I'm also an autodidact. So I'm not a scholar like the other speakers, but it's actually my full-time profession to give webinars, to give keynote presentations, and to do consulting on the topics of human enhancement, human augmentation, biohacking, transhumanism. So how do we as humans look in the future, and what kind of implication, also like Anders mentioned, what kind of ethical questions do arise? And if you like this talk, I also have a YouTube channel and also a blog, and I will share a link to that at the end of my presentation. So let's continue. An interesting question is, what actually makes us human? And there are different answers to that question. And I'm also curious, type in the chat if you have an answer to this question, what makes us human? I will give you a couple of answers. You can think of that we have stories to tell each other, that we can forecast the future, that we can plan into the future, to also think about possible ramifications of our own actions, that we know how other people react, or that we think about it. Maybe also because we as humans, we are conscious, we have consciousness. And I think these are all valid answers. But one really important thing that distinguishes us as humans from other species is our use of technology. That's one of the main points I learned from Professor Peter Balverbeek from your, I don't know, it's a competitor of Eindhoven, I'm not sure, but it's in the Netherlands, Enschede, and he talks a lot about the use of technology, and the use of technology is what makes us human. So you can think of the wheel, of fire, of agriculture, maybe even of the internet. And compared to other animals, we do not have like specific features, like we don't have wings so we can fly, or very sharp claws, or maybe sharp teeth. But what really distinguishes us from other species is the use of technology. And transhumanism technology takes that a notch further. So we do not only use technology to increase our lives, but really lift us up as humans, to become more than human, to, as Anders also mentioned, to elevate the human condition. So I want to zoom in really quick on 3 transhumanist technologies, because the main idea of transhumanism, we see it a lot in popular media. So I'm also curious, if you're watching, please leave a remark. What's your favorite science fiction book or series or movies on the topic of transhumanism? It was also one of my bingo card items, so maybe you will also score some points with that. And because in movies, the transhumanist idea, it has a lot of appeal for directors, for writers, for authors. For example, you just saw Passengers, Transcendence, where we have mind uploading. And maybe you're watching and you think, okay, Peter, that all sounds a little bit science fiction. Well, that may be the case, but one major takeaway of my presentation is that there are already researchers, engineers, entrepreneurs working on all these kinds of ideas and technologies. So the timelines may differ, but they're actually already working on it. And the first technology is, how can we increase our health span and our lifespan? So you are probably familiar that you should have a decent, a healthy lifestyle with enough movement, good nutrition, enough sleep, but also think of your stress levels with the use of meditation and yoga. But still, if you lead a healthy life, that still can get you, I think, till 120 years old. Or there was also a recent study where they say the maximum age that a body can become is 150 years. So there's still like some border in biology. But just like the previous speaker, Anders Sandberg, mentioned, there are already scientists thinking and working on ideas. For example, Aubrey Gray at the SENSE Foundation, Andrea Meyer, and they're looking at different causes of aging, but also different solutions to halt or even reverse the aging process. So you can think of genetics, maybe genetic modification with CRISPR. That might be an interesting question for Kevin Esvelt. And you can also, of course, think of your own methods to stay healthy. For example, taking ice baths or doing Wim Hof method breathing. So that's the first one. How can we increase our longevity? And still, compared to the swimming in cold water, you can also use cold to give you a boost with the use of cryogenic therapy. And this is where you get into a cabin for 3 minutes of minus 109 degrees Celsius, so it's about 160 degrees Fahrenheit, and it also gives you a boost to your body. And cryotherapy is becoming more popular, but you should not confuse it with another cryo technology, which is also one of the main transhumanist idea, namely cryonic preservation. And cryonic preservation is, at the moment, you did your best to lead a healthy life, but in the end, you still die of a certain disease. Then you can also, during the times years you were alive, you can pay a heavy subscription fee to a couple of institutions, and this is the institution you can see on the picture is well known, is Alcor. And this is Max Moore, just like Anders, one of the rock stars in the domain of transhumanism, but he's also the director of the Alcor institutions. And there you can preserve your head or your whole body. The latter one is also where you pay a higher subscription fee. And then you are being re-awoke after 50 years, after 100 years, when the technology is up to date to make you come alive and also to help you cure from the disease in which you passed away in our current day and age. And this sounds like, oh, this is from the series, from the movie Passengers, for example, but still there are already people in this state. This is sort of estimate about 200, I think. And also the first person that got into this cryonic state was in 1967, was James Bedford. So still, my main takeaway is you think of these things as science fiction, but it's actually already happening. But what if you think about, do we still need this body? And do we need to do everything to keep this sack of flesh or this bag of water to keep it fit and healthy? Why can't we upload our consciousness, our brain into the cloud or into a robot? And just like I mentioned with the other technologies, this is already something that scientists are working on. This is an interview I did with Randall Koenen. He's a Dutch neuroscientist. He works for Cornell and Neuralink, but he's also the founder of Carbon Copies. That's an organization that strives to further the development of brain analysis, and then also that you can emulate it and also upload it into the cloud of our computer. And it also makes me think, that's maybe a better solution for some problems that we will face in the long term as human species, because our bodies, our frail human bodies, they're not made to stay alive in space because of radiation, lack of gravity, these kinds of things. So one day in the future, we have to leave this planet Earth because the sun is getting too hot. And if we want to go to other galaxies, probably the best form is to be as a sort of uploaded astronaut, that we live in silico instead of this biological matter. So these are all things that are already in the works. So I want to end with 3 takeaways. The first one is that technology is what makes us human. And the second one is that all these things seem to be directly from a science fiction book or movie, and they have different timelines, I should admit, but they're already in the works. There are already researchers, designers, entrepreneurs, also philosophers thinking about these ideas. And the third takeaway is that I think it's important that we also ask these questions like, is having a body, does that make us human? Because that also means how we want to apply certain technologies. So I think it's important that we think about it, talk about it, discuss it with each other, philosophize about it. And besides having scientists, we also probably need imagination, philosophy, and maybe also a little fantasy, just like I had when I was playing the game Deus Ex. So if you like this presentation, you can go to this website, or even better, you go to thistiny.cc/stkn, where you can download this presentation and also subscribe to my YouTube channel. So thank you, and I will look forward to your questions and also to the panel later on.
Thank you, Peter. Well, if you put all of that in order like that, it's almost a shame that with Team HART we can only focus on one thing at a time. Because there seems to be so much. Now, there was already an answer to the question you posed, and I guess the gist of it is what differentiates humans from other living entities is our ability to become self-conscious. What's your take on that?
Yeah, that's, I think, a really nice answer from Adriaan Fromoulet. I hope I pronounced your name right. That indeed having a consciousness is also what sets us apart from other species. But still, I think the jury is out, because I think I'm curious if there's not like a really clear answer. And I think what makes us human is, like Anders Sandberg also mentioned, was also already a main idea or a main point of dilemma in the Renaissance, and even Greek philosophers were thinking about it. So I hope we can use the progress in science and technology to give us a more detailed answer. But I think Adriaan's answer is right on the path to what we once will know about ourselves.
All right, great. Then I see here another interesting question from Robin Nagel. What is the most popular argument against human augmentation that you've heard in your talks? People are most afraid, and I think that was also remarked by Anders, about the speciation. So that there are certain types of technologies, be it increased longevity or maybe neural implants or other things, or CRISPR, that are only available for people, A, that are willing to use that kind of technology, but B, also able to buy the technology. And that you, instead of having a cultural divide between certain classes in society, or even a social cultural divide, you also get a biological divide, where the rich are able to buy these kinds of upgrades and live longer and be smarter, just like in the series Altered Carbon, for example. Yeah. All right. Yeah, might become a problem eventually. I also have in that trend a question from Neon Cyborg, which basically asks whether you think what the balance will be between these kinds of transhuman beliefs and religious organizations, and whether they will clash maybe at some point.
Oh, yeah, that's a really interesting question. Also, an interesting name, by the way, Neon Cyborg. So kudos for that. You already see it happening. So there's a lot of talk that transhumanism is a new religion, and that we also, our belief in technology. There are also some elements. For example, think of the mind uploading. In a way, you can see that as a sort of heaven for us as a sort of as humans. So there, But what's also interesting, I want to share with you, is that I also went to a course a summer course at a university that was also connected to the Vatican Church 2 years ago. And what really surprised me, I must say, I'm an agnostic or atheist. What really surprised me is that the Vatican actually is already thinking about it. We had a course on genetic modification, on CRISPR, on doing it with embryos. That was also really in the headlines at that day and age. So they are aware of it, and I think they also need to adapt, like they also did in history when certain new technological developments came. But I'm curious also, maybe this is also an interesting question for the panel. If we see transhumanism as a new religion, or if other religion will also adapt some of the ideas or technologies. So really interesting question.
All right. And then we have another interesting question here from Jonne S., which is various animal species have mastered some form of tool. It could be elephants, chimpanzees, or ravens, and even some tool crafting. But what do you think differentiates this use of tools from technology that humans work with?
Nice question, Jonne. You paid a lot of attention and you came with a critical question. So I think that also distinguishes us as humans, that we also think critically. What I think is that we also combine our specialty, that we use technology, with another other characteristic that also was mentioned in one of the previous question, that we also have consciousness. And one definition of consciousness is that you can plan ahead, that you have ideas about how things are going to play out if you use the technology. And I'm not really aware if elephants and chimpanzees and ravens have the same kind of future planning when they use their kind of technology. So it's really interesting question. But if I have an answer, I would think that it's the combination of these two elements.
Okay, and then maybe I have one more question from our side before we go into the break. You mentioned the Deus Ex games. I was also a big fan of those in the past, and specifically indeed the modifying of the human body there. But of course, I believe you're no stranger to tinkering around with the human body yourself. And I was curious, what do you think the ultimate human looks like, and what forms of enhancing human abilities are you yourself looking forward to the most?
Like I mentioned, I have also, as a cyborg futurist, I also have implanted technology in my hand, the so-called grinder technology. So I have now a chip where my contact information is on it, and in a couple of weeks I have another chip in which I can pay. I think that this also, if you talk about the future, the best way is also to experiment and really feel how the technology is influencing your life and how other people respond. And I think in the most ideal sense, I think I will follow Anders Sandberg's example, who talked about the open future. I think it will also be interesting that you have also a morphological freedom, that you can decide for yourself how you want to shape and enhance and augment yourself. And I think for me, the ultimate enhancement is, I like to do sports. So I would like to have some bionic legs and some artificial blood and some maybe some other things. But I also like to increase my brain power. So maybe combine different sources in a faster way with each other. So I'm not sure how the future human looks, but I kind of fell in love with a major from Ghost in the Shell. So if I go for one, then I go for that as the human of the future.
Okay, clear. A lot to look forward to, I'd say. Peter, thank you very much for the talk, and we'll see each other back at the panel discussion. And then I think it is time for us to go into the break and have some more interactive questions for the audience.
Yes. Okay, so now we're going to continue with what we started in the very beginning. So if you go to teamheart.nl/break, you can participate with us. We're not going to take the entire break, of course. We also want some time to get coffee or something. But yeah, and also don't forget, meanwhile, about the bingo. The speakers are also very much welcome to participate. So yeah, let's just go on with the questions. And the first one, we want to find out a little more about you. Like, what country are you watching us from? We are here in the Netherlands, but some of our speakers are from abroad. So, yeah, I see UK, United States, yeah, of course, the Netherlands.
I think the Netherlands is going to be quite dominant here.
Yeah, I mean, that's not surprising. Curious if there is something else.
Limburg, yeah, that's definitely a separate country.
Oh, Ireland. This is interesting.
Switzerland.
Switzerland, yeah. Wow, welcome.
Wauw.
Is that
Yeah, that
is
is
it
that is.
some parts of the Netherlands?
I think this
probably,
is their
right?
Declaration of Independence.
Nice. Okay. Yeah, a lot of Netherlands. It's really big on the screen. Yeah, I really like the fact that Limburg is now a country.
I've always said it was.
Yeah, well, it's hard to argue. People there do sound differently than
Maybe it could use some more Russia, Maria, in the future. Finland, even.
Finland. Yeah, that's closer to home.
Uh,
Come on, nobody from Russia? That's too bad.
all right, yeah, this gives a nice overview, I'd say.
Yeah, yeah. Okay, let's learn a little more about you. Now, we want to know, how old are you? Like, we
I'm
are
wondering-
actually very curious if there is somebody who is less than 16 years old.
Or maybe in the future we should also include the category of 150 plus.
Oh, yeah.
That would be nice.
But I think we have to wait for a little more
Yeah,
transhumanist developments.
We have to do some more work first.
Yeah. We'll get that, don't you worry. In our next symposium, there is going to be an option 150 plus. Yeah. But I suppose, yeah, most of the people are 16, 25, so probably students like us.
Is of course. Ooh, there we get the first 60 minus.
Yeah. Yeah. Yeah, that's great. Okay. Okay. That's interesting. Yeah, we have a spike at the student and then a spike from smaller one from 46 to 60. I'm really happy to see somebody less than 16 years old. It's really great.
Can never be young enough to learn.
Exactly. Okay, so let's go next. So what university did or do you attend? Yeah, us both, we study at TUE, of course. So the students, yes. None.
Hmm.
Okay.
Ooh,
This is an interesting
a
university.
nice strike through.
Oh, it's gone now.
Wageningen even.
Yeah. I had hotel school,
Cool.
Groningen,
Porto.
Porto. Nice. What is NCOI? I actually don't know. Red Cloud.
And COE. Oh, yeah.
Quite a wide range of Dutch universities, and there's Oxford. Also, they
Nijmegen.
under Sandberg, who works at Oxford.
Yeah.
Very-
Radboud, yeah, of course.
Yeah. More universities than I expected, also outside of the Netherlands.
Apparently, it likes to center TUE very much.
Yeah.
That's not
Nijmegen.
pre-programmed.
I really love the none yet option.
That's maybe the 16-year-old.
Yeah. Yeah, less
Or
than
younger.
16,
Yeah.
Okay, yeah.
Nice.
Uni of Southampton, nice. Okay, quite a large diversity. So TV is much smaller than I thought it would be. Okay, let's learn something else about you. So, what field are you closest to? So, yeah, we would probably belong in the engineering and sciences category, as probably would most of our speakers. But yeah, transhumanism doesn't just relate to those, and it's very interesting to learn about it from all different kinds of perspectives.
Quite a nice distribution.
And there's quite some business.
Yeah. Ooh, even repair and installation. But we
That's
need to
nice.
target more law people next time, I guess.
Yeah, and sales.
Oh.
Here goes sales. Yeah, nobody from law, which is actually quite a shame because probably we're
Well,
going to need
yeah,
some
legislation at some
regulations.
point.
Yeah.
It can become a
Okay.
focus for us.
Yeah. Yeah, for sure. Be something to look into. Okay.
Good to
Okay.
see.
Yeah. Let's go next. So, what superpower would you like to have? If you could have one, which one would it be? Which one would it be for you, Victor?
Ooh, I really like the idea of flying or a 360-degree
Flying.
vision.
Oh, between these two, I would totally choose flying.
Yeah. Ooh, telekinesis is also cool.
Yeah. I think I might go for teleportation, especially during Corona times. So I could now end up somewhere on
Avoid
the
public
beach.
transport. Oh,
Also that. Ride a bicycle. That's an
fast
interesting.
running. Dat might be
Yeah.
beter.
Might be. Shapeshifter. Oh, this is awesome.
I love the ride a bicycle one. Somebody
Yeah,
thinks
yeah.
all Dutchies are superheroes.
Totally. No,
Mind
but I
reading.
think that, senior people riding bicycles, I always view them as superheroes. Especially when they just moved to the Netherlands, it was such an interesting sight for me. Because you can't see an older person riding a bicycle in Russia.
Yeah,
Wow, we
yeah,
have
yeah.
so many superpowers.
Oh, super
wow.
cooking skills.
Eidetic memory. Oh, that's awesome.
Eat and don't get fat. Yeah, that's
Freezing
definitely a
time.
good
That's
one.
perfect during exams.
Enhanced memory. What do you think about that one?
Oh yeah, I would love some of
Yeah,
that.
that could be nice. If somebody could invent that in the next 2
Yeah.
weeks, that would
I think we
be
can
of great
just
help.
we can use this slide as inspiration for our further developments. Wow. Well, we're definitely going to
Speed
look
reading.
at this.
Yeah, I mean, this is gonna be perfect.
Yeah. Okay, I think it's getting a little bit unreadable, so let's move on. So yeah, here's a bit of a fun question. What would you be doing now if you weren't watching the symposium? It's just to make you feel good about actually being here, because otherwise, you would be not studying for your exams or procrastinating. I would probably be watching Netflix or sleeping. Yeah, with exams coming at TV, a lot of people would be not studying for exams as expected. And other waste of time.
Yeah, maybe I would be watching Altered Carbon on Netflix.
Oh yeah, I really want to rewatch it. Actually, Altered Carbon was the trigger for me when we decided to
Cool.
launch Team Heart. The idea was cooking for some time, but Altered Carbon actually triggered it.
You can do a marathon of it in the holiday somewhere.
Yeah, we should do that for sure.
It's gonna be a team activity.
Yeah, mandatory team activity. Okay, so not many people would be procrastinating or sleeping.
That is, I mean, the not procrastinating part is good to see, I guess.
Yeah, but sleeping is surprising. I would probably be in the sleeping category. I love sleep.
All right.
Okay, so you're just for the rest of your break. Just enjoy it. Go to networking rooms, fill in the bingo, and we will be back at what time? We will be back.
8:05. So in 7 minutes, I guess.
Yes. Okay.
And who
See
is
you
gonna be
then.
talking then at Boyden?
Yes.
Oh, that's gonna be very nice.
Okay. See you then.
See you.
So we are back from the break, and our first speaker is going to be Ed Boyden. He's a professor of neurotechnology at MIT, an investigator of the Howard Hughes Medical Institute and the MIT McGovern Institute, and a professor of brain and cognitive sciences, media arts and sciences, and biological engineering at MIT. He leads the synthetic neurobiology group, which develops tools for analyzing and repairing complex biological systems, such as the brain, and applies them systematically to reveal ground truth principle of biological function, as well as repair this system. He received numerous awards for his work and was elected member of the National Academy of Sciences in 2019. And now he will give us a talk about technologies for understanding and repairing the brain. So Ed, the stage is yours. Welcome.
Still probably need to share slides.
Great to be here. Yeah, and excited to talk about one of those complex things that we study and that presents huge amounts of challenge, which is the brain. Let me try to share my screen here. Okay, is this working now? Great. So I lead a group at MIT that works on technologies for seeing and repairing the brain. The brain is incredibly complicated. A cubic millimeter of your brain will have 100,000 brain cells connected by 1 billion connections called synapses. And to make it even more complicated, each of those synapses and each of those neurons has chemical and electrical signals that last about 1,000th of a second. So a huge number of processes happen in even a cubic millimeter of the brain every second. And of course, the brain is much larger than a cubic millimeter. One of my dreams is, could we understand the brain to the point where we could simulate decisions, emotions, or other complex brain phenomena in a computer? And ideally, that would be human understandable and biologically realistic. Now, in order for that to happen, we need to develop many technologies for seeing and controlling the brain. Of course, another reason to do this is we want to be able to understand brain diseases as well. Brain diseases affect perhaps over 1 billion people around the world, none of which can be fully cured. And for many diseases like Alzheimer's or stroke, Parkinson's, and epilepsy, there's not a lot we can do. So there's great clinical need. So we want to be able to observe what's going on in the brain, map what's going on in the brain, and control it. How do we map the brain? Well, the brain, of course, has many different spatial scales. Brain cells are enormous objects, and as I alluded to earlier, the density of the wiring is nanoscale. If we want to see how the brain is organized, we have to make a map of the brain cells throughout the brain and the molecules throughout those brain cells. Now, I think we've all seen images like this, brain scans. While non-invasive, they're not very spatially precise. Each blob or voxel might have millions or even billions of brain cells in it. At the other extreme are microscopes, but even they struggle to image nanoscale things. So in our group, we often try to do the opposite of what people have done in the past. We wondered, what if we could chemically weave a dense spiderweb-like mesh of swallowable polymer, basically the stuff in baby diapers, inside brain cells and outside brain cells, in between biomolecules and around biomolecules. Do it just right, add water so that the baby diaper material swells, and could we make the brain physically larger enough that you can make a map of the brain? So about a half decade ago, we showed that we could do that. Panel B shows a small piece of the mouse brain. Panel C, the same piece of mouse brain, about a day and a half later. We permeated it with a dense mesh of polymer before we expanded it, and then after we added water, we could blow the brain up to make it much larger. Now we can express glowing proteins, like from jellyfish or corals, in brain cells using gene therapy vectors. Then do the baby diaper chemical synthesis, add water, and blow it up. If you image a piece of the color-coded brain with a regular microscope, you get an image like at the top middle, looks fuzzy. But if you expand it first, you get something like in the upper right, much more detailed wiring. So my dream is maybe we could actually make maps of the brain so detailed, the molecules throughout brain cells and the brain cells throughout networks, that maybe we could try to simulate behaviors, decisions, and emotions. Now, an interesting thing about building a technology for confronting the brain is that it often helps with other problems. And after we showed the world that we could expand the brain, many people came to us and said, can you help with my problem too? It turns out that many of the leading causes of death, if you diagnose it earlier, you can save more lives. For example, if you catch a cancer before it spreads. So we started expanding cancer biopsies and wondered, could we help make the early, subtle changes into big, obvious ones? Early in a disease, after all, it's hard to see what's there. If we could expand the biopsy and physically make the small changes large, maybe we could help people diagnose diseases better. And that's something that now we're actively exploring, with many doctors expanding different kinds of tissues and biopsies to see if the early small changes in a disease can be made larger. This, by the way, illustrates a kind of pattern that our group often performs, which I call invent, discover, design. We invented a tool, the expansion method, that lets you see nanoscale tiny things with regular microscopes. We are helping people make discoveries, like the fact that you could see an early stage of a tumor. And then finally, we design practical strategies for getting them out into the world. Now, of course, one of the obvious limitations of expansion is that it doesn't work on living things. And so in the second part of the talk, I want to talk about a strategy for controlling brain activity while it's alive. The basic idea, which we call optogenetics, is basically the idea that we could control the electrical activity of brain cells by putting little solar panels in them, molecules that convert light into electrical energy. Then you can bring light into the brain. That's not so hard because the brain doesn't feel pain. You can bring an optical into the brain and activate the brain cell. Turns out, all over the tree of life, you can find molecules from microbes that convert light into electrical signals. Light-driven proton pumps, like the one shown on the left, light-driven chloride pumps, like those in the middle, light-driven ion channels, like those shown on the right. These are proteins found in single-celled microbes all over the Earth. They're used as primitive photosynthetic or photosensory molecules. They're encoded by genes. If we put the genes into brain cells using commonly available gene therapy strategies, then we can shine light on the brain cells and pump or transport ions, charged particles, from one side of the neural cell to the other. Then we can turn neurons off and cancel out their activity. That's what the light-driven proton pumps and chloride pumps enable. Or we can activate the neurons and turn them on. By deleting neurons momentarily, you can figure out what they're needed for and turn off pathological activity. By activating neurons, you can figure out what they can drive and activate potentially healthy activity. That's the invention. Now, what about the discovery? Well, thousands of scientists, just as with expansion, are using optogenetics to study the brain. I'll give you one example from Li Wei Sai's group at MIT. She used our light activator to show she could drive the mouse brain at a specific frequency, 40 times a second. And these are mice engineered to get Alzheimer's-like symptoms. Could you treat Alzheimer's with a brainwave? Amazingly, these mice got better when she drove the brains 40 times a second. Now, that's the discovery. Is there a design that could be brought into the world? And under her leadership, the collaborative went on to show that you could drive these same brainwaves by basically having the mice watch a movie, show it a flickering light, and give it a clicking sound. And so that was also able to help the mice get better. So now there are clinical trials that are ongoing with actual Alzheimer's patients asking, could you use a movie to treat Alzheimer's disease? I think of optogenetics as a tool for science, but some of you may have seen that a few weeks ago it was announced that a European team has shown some success in directly using optogenetics in human patients with blindness. These are patients who've lost their photoreceptor cells in the eye, but by putting these photoreceptors that our group discovered, like a molecule called crimson, for example, into the eye of a blind patient, they could see again. The vision is not perfect, but it's early days, and my hope is that the partial restoration of vision that's been shown in a patient in a trial that José Alain Sahel and Bolton Ruska and others have overseen will potentially enable even better vision in the time to come. So these are two examples that I want to tell you about today, where we invented a tool to show people science they couldn't see before. People went on to make discoveries using the tools. And finally, there are practical designs that can be brought into the world to help people. But back to the original prompt. How can we make a model of the brain that allows us to potentially try to simulate decisions or emotions? And furthermore, can we make maps of the brain that help us systematically understand brain diseases? Those are outstanding challenges, but one of my hopes is that we could try to make maps of small brains relatively soon. Imagine if we could look at brain activity in a small organism like a worm or a fish, which is now being done by many people. We can use the optogenetics to perturb the activity, and at the end of the day, we can expand the brain and make a map. Can we bring those data sets together and make a simulation of the brain? My hope is that this will become possible in the years to come, starting with small brains and potentially being scaled up over time. This could have huge impact in AI. It could help us understand something about the human condition. What is a thought, really? What is happening in our brain when we have an emotion? I'll end there, but I just wanted to note that this is a very large collaborative project with many people, both in our group and our alumni at the top, and an even longer list of collaborators all over the world, shown in the middle. And with that, I'd be happy to take questions.
Yeah, thank you very much for the amazing talk. We have quite a few interesting questions from the audience. And let's start with the one from Anders Sandberg, who is asking, could we tell synaptic strength from the expanded version of the synapse?
Great question. So when we expand the brain, we're expanding all the molecules away from each other. So it looks to the eye like you zoomed in with a microscope. And that's one reason why it's very popular. Already over 250 papers doing expansion have already come out. Now, can you take the image and correlate that with synaptic strength? Well, to be honest, nobody's really proven that there's a strict linkage between those in any full set of synapses in a brain. In fact, we don't even know how many cell types there are in most species. So that would be a goal to see if we can use our imaging method or any imaging method to infer synaptic strength. And synaptic strength is only the beginning. You also want to know where the ion channels are, right? Some cells might be very excitable. Some might be very quiet. Give it the same synaptic input, and two cells might be doing completely different things. So hopefully we can start to map out the strategies all over the brain of how brain cells communicate and compute, and that could be quite powerful.
Okay, nice, thank you. There is another question from Anna Riznavel. No, oh my gosh, I'm so sorry. How reliable is the mapping of the brain? The function of different parts are known to change when we age or when we suffer from injuries. How reliable is that?
Many people are using expansion to look at different problems like aging or injuries. I'll give you one example that we also did with Li Wei Sai, the person who pioneered the Alzheimer's movies that I mentioned earlier. What they are finding with our technology of expansion is that when we expand an Alzheimer's model brain, we can actually map pathology and reveal patterns of protein organization that have not been seen before. And so my hope is that indeed the expansion process will make brain mapping very reliable to look at these changes that are due to aging or after injuries.
Yeah, that'd be really great if it was the case. Meanwhile, the next question from Nigel Visser. Doesn't this kind of optical activation method only work on the surface area, or do you use a fiber optic inspection tool at certain places?
So you can do both. You can deliver red light, which goes deeper in the body because it's not absorbed by the blood. That's why blood looks red. And we and others have developed less invasive strategies for brain activation. In fact, the molecule that I mentioned, which is helping restore partial vision in human patients, is a red light activated molecule to help get the light in. You can also bring a fiber optic cable into the brain, and many people are doing that as well in animals. That has not yet been done in humans. But for example, in the example where Li Wei's group discovered a brainwave that could help with Alzheimer's, that was initially done by putting the gene for our molecule into the brain and then bringing a fiber optic into the brain aimed at those cells.
Mm-hmm. Okay, thank you very much for your answers and for the presentation. We'll continue with more questions during the panel, but now it's time for the presentation of Yoeri van den Burgt. Uh, Welcome, Yoeri. So,
Hello.
hello. So Yoeri van den Burg obtained his PhD degree at Eindhoven University of Technology in 2014. He then worked at a high-tech startup in Switzerland, after which he obtained a postdoctoral fellowship at the Department of Material Sciences and Engineering at Stanford University. At the end of 2016, he returned to Eindhoven as an assistant professor, where he currently leads the neuromorphic engineering group. He has also been a visiting professor at the University of Cambridge. And he will give us now a talk about organic neuromorphic materials for adaptive biointerfaces. So, Yoeri, the stage is yours.
Yeah, thank you. Thank you very much for introducing me. Also, thank you very much for inviting me to this great symposium. It's actually very fun to see all these different perspectives on the transhuman vision. I renamed my title a little bit to be a little bit more in a discussion form. So I'm a material scientist, and we work on materials to do things like building a brain on a chip and biohybrid systems. In a more detailed word, that would be organic neuromorphic systems. And I try to highlight in this talk a little bit what the vision is of these materials and why we work on them. And I would like to start actually by introducing a very familiar topic to everyone, I guess, by now. It's artificial intelligence. And previous speakers already touched upon it. But AI nowadays is basically adapting computer systems to emulate sort of brain-like functionality. So they can make systems, machine learning, that can actually be trained to improve itself with experience. So you can feed it information and it learns and it becomes better. Now you know a couple of examples of very recent applications like face recognition on your phone to unlock it. That has been recently introduced, but there's also image recognition on tools like health diagnostics. But you know, image recognition can also be more futuristically seen in this example here, in this picture that I found somewhere, where it can be used in companies or even governments that can recognize different people instantly. And there's also some ethical discussion that we can talk about here. Another nice example of this, and that's the last example I'll show, is self-driving cars. Although they have still been a promising technology for more than a decade now, it's still something that is being developed very well. And you need systems that can train and that can learn from data that they find online, that they can find, sorry, not online, while driving from other people on the road. Now, in a nutshell, most AI systems are based on algorithms called neural networks. And on this slide, there's a couple of them, there's many more, and I won't go into details. But the important thing to understand here is that these networks rely actually on the modification of the connections between these layers of these dots here. So the hidden neurons and the synapses of this neural network. And there's actually, AI is not actually very new. In fact, it's been around for decades. And there's two reasons that this time it is actually increasing much more rapidly and is here to stay. The first is the vast amount of big data that is available nowadays to train the networks. And this is just an example of a lot of images. But again, these systems can only become better by learning, by training from examples, such as shown in this picture here. And the vast amount of images that we are all uploading every day onto the internet nowadays. For instance, neural networks you can very easily train with labeled data that you can actually get from a software system called, or software database called ImageNet. And it's important that these are labeled, otherwise the system cannot be trained. Now, the second change was actually the development of graphical processing units. And they have been used in dedicated neural networks and greatly improved the efficiency and speed in these neural networks. And if you remember that all these networks have all these different connections that need to be updated, you need to do this in parallel. And the idea here is that GPUs have many cores in parallel, so they can do many calculations in parallel. That's why they become so important for these AI applications. And this is just a simple graph. It's relatively old by now, but it highlights the implementation of GPUs for AI, where you can see that near the end, the potential of these GPUs has been proven by outperforming humans actually in this ImageNet example of images that I just showed you. And in 2016, actually, a computer won against a human player in this Google DeepMind. Google DeepMind won from a human in this game of Go, and Go is actually a very complicated game that you cannot before the game tell all the different moves that you can take. So it's really something that the computer had learned. So it's not done by remembering, it's just by playing against itself and improving on that. However, that took a lot of computing power. And there's some calculations to compare between the human and this data center here, this computing center here. But it's about 10,000 times more energy that is used. Now, this is where material scientists come in. This parallelization of these neural networks was also introduced by so-called memristor arrays. This is just a SEM image of a memristor array, where the devices actually have a memory component in the center of these crosses, and that can actually be modified depending on the history of the device, how it was operated. So you have some memory part fulfilling the memory of the computing part. Now, this is actually very similar to the brain, and this is where the brain part comes in, where the brain, and I'm not a neuroscientist, so I'm glad that the previous speaker actually introduced this topic very well, but the brain consists of neurons that are processing units in the brain, and they're connected via these synapses here, these red dots in the center. Now, these synapses can actually change their conduction, their resistance to each other, and that depends on the activity of those neurons that are involved in that synapse. Now, if neurons talk to each other very often, those synapses become stronger, and you can actually memorize or get a better connection between those neurons. So you memorize, you learn something. But as a result, the brain activates memorize something that is activated very often, and it can do this actually by physically moving the two sides of the synapse together. Now, this is exactly what we have done in a device based on organic materials. So we have a plastic, organic material, and the resistance of the bottom polymer that you see in this schematic here, the blue part, can actually be tuned by moving in ions from the top part. Now, we can thus perform the memory part of neuromorphic device. We can train it by learning from inputs. And this is actually, if you look at the synapse compared to our device, it's kind of similar. So we have mixed electronic ionic connectivity of a polymer. We can non-volatilely electrochemically dope this, and we can actually show short and long-term potentiation. Now, the first devices look a little bit like this. So large flexible ones or smaller arrays. But obviously, we want to go to more flexible, larger arrays. And this is an organic memory array from Professor Someya's group in Japan. And the nice thing about this is you can already see this is also very interesting to be able to interface with the body because it's flexible. You clearly see that this might be connected well. And this is where we touch upon a new research field. As on the biological side, we have this field called bioelectronics, where we interface devices and materials with the body to monitor and control or restore functionality. Now, as an example, we have actually used our organic device in combination with real synapse, with real cells. So we have made a biohybrid device that can actually learn, and this is the only real graph I show you in our slide, where we have this neuron that actually talks to our organic polymer in the blue there, and by releasing neurotransmitters, it can actually change the conduction of our organic device permanently. So you see a short-term modulation from the synapse and a long-term modulation here. There's a difference between the conduction between the starting and the end. So what it actually does, it memorizes, not only measures, but also memorizes the history of pulses from this neuron. So you have an adaptive interface between a neuron and an organic artificial device. And this is where we can think about applications like local control, trainable prosthetics. You can imagine that you can control controlling these prosthetics uses a lot of computing power. And if we have these adaptive interfaces between our nerve cells that control the hand and the prosthetic itself, we can actually improve this connection and let, for each connection, for each person be adapted personally. So you have a more personalized connection between those two. In the end, you can think of other things. I just highlight a couple here where you have some adaptive drug control depending on the need of if you have a seizure or you have some other need of drug control, you can do that locally without a computer controller because the devices can be adapted locally. So we have here the adaptive prosthetics, or even thinking about interfacing those electrochemical adaptive devices with the spinal cord that might be broken. So you combine artificial intelligence using materials with our body. I'm a little bit over time, so these are just my acknowledgements, and thank you very much for having me, and I'm happy to take any questions.
Okay, thank you very much for your talk. Really interesting. So we have a question that's kind of related to what you said. You can control like a bionic arm or something, but a little bit to a different direction. Would it be possible to use this technology in the future, maybe to transfer memories to a machine or something to continue on living if the human body fails?
I think that's a great question. So in the end, it has to be something like a material that is more related, more suitable to functions like the brain. So if you want to copy the brain somehow you cannot just measure the activity with the gold electrodes. You have to also do something with your neurotransmitters. You have to do some, brains actually talk with ionic currents going through the synapses. It's not electrical currents. There's some electricity, but it's not. So you really want to have something that is more related to the brain itself. So yeah, definitely, it's going to be very complicated, but I foresee that it has to do something with a material. You have to do it with a material that is more related to how the processes in the brain work too. So yeah. Who knows?
Nice. This is really exciting. And we have another question from the chat. How is the stability of I can't read it. Can you?
Chemicals.
Yeah, P.PSS in biological environments.
Yeah. So Nigel would expect some polymer degradation over time, especially in P.dots is also used OPV, which tend to degrade. I don't fully understand this question, but hopefully you do.
Yes, I do. So P.PSS is indeed used in solar cells as an interface layer. So what we have to do with P.dot is to add a crosslinker. So you add some crosslinker during your spin coding, and then it's highly stable. So there are actually interface devices based on P.PSS that are currently in use and approved by the FDA in the United States, and they can be implemented in long term. Colleagues of mine work on these long-term implants in mouse, in rats, in other larger animals, and there's no degradation as long as you have this crosslinker. So you're right, for OPVs they don't use it, and then it degrades.
Okay, thank you. Here's another interesting question from the chat from Ewout. He's asking, instead of moving a limb, would it be also possible to connect the biological chip to the internet and surf the internet with your brain?
Yeah, so for sure, we're doing the fundamental work of the materials, but if you look at Elon Musk's Neuralink project, which is basically what he claims in those kind of things, right? You can do everything with thinking about it and moving things and surfing the internet. So their devices are just probes that measure activity of cells using conventional electrodes. So our devices are not only measuring but storing. So in principle, I would say it becomes easier to do those kind of things because you can measure not only activity but also, if you're happy, you have some other neurotransmitters that are released that you can actually sense too. So you can do more with emotions than just with activity. And I think it's definitely a long shot in the far, far future. But if you connect somehow correctly the brain to our chip, then sure, why not?
Yeah, nice. Do you think this would make the exams obsolete?
So if you can do it bidirectionally, so you can also copy back something, yeah, then for sure, yeah. But maybe exams would become even more difficult because it turns out you have to find somewhere in your mind where the answer was, right?
Yeah, okay. Thank you. And there is another question from the chat from Reynoud. What is missing in the materials department that make current implementation so difficult?
Yeah, so this is, that's a very good point. And it touches upon the difficulty of research nowadays, which is actually that it's becoming more and more multidisciplinary. So, we can make materials, but we need anesthesiologists, we need surgeons to put those things in brains. We have to work together with huge consortiums. You saw in previous speaker someone who actually has those huge consortiums. You see all the names on that list. So for me, that is actually the biggest bottleneck, finding the right and the right amount of money and people to work together in bigger consortiums on these things. At the same time, materials, devices like these are very fundamental, and they actually also need optimization and scalability issues to be overcome. But that's more a technological problem than a fundamental one.
Okay. Okay, thank you. And the last question from Mark. And can a person restore emotions and facial expressions in Parkinson's disease?
I'm not an expert, honestly, on that disease, and also not on the issues. What I do know from my colleagues who work on bioelectronics is you have these implants in people who have Parkinson. And when it's basically a bioelectronic device that gives pulses at a certain region, and when they switch it on, actually they lose all the tremors and they can just function normally. So there might actually be some solution also for facial expressions or emotions if you don't have these tremors anymore. But I'm not an expert. I would hope so.
Yeah, let's hope so indeed. But yeah, thank you very much for your answers, for your amazing talk. We'll continue during the panel discussion.
Thanks for having me.
Thank you. And now I want to introduce Kevin Esvelt. He is a MIT professor who leads the Sculpting Evolution group in exploring evolutionary and ecological engineering. He is the creator of a synthetic ecosystem to rapidly evolve molecular tools, and he is best known for inventing a CRISPR-based gene drive system capable of single-handedly editing wild species. He is the leader of efforts to ensure that all research in the field is open and community-guided. His laboratory broadly focuses on developing new molecular tools and safeguarding biotechnology from mistrust and misuse. And now he will give a talk about sculpting the evolution of biology and technology. So welcome, Kevin. The stage is yours.
All right. Well, thank you so much for the opportunity to talk about something a little bit different than I normally do. I'm going to try to weave together a number of the themes that we've heard about so far today, from the philosophy to the science fiction to the actual science. And admittedly, as you heard, I tend to focus a bit more on engineering ecosystems using evolutionary engineering. But my lab is called Sculpting Evolution because we study the evolutionary process, which doesn't just apply to biology. It also applies to ideas, to culture, to technology. So what we're interested in is this question of, can we sculpt the evolution of technology to discover those that we think will be beneficial and stay away from those that could threaten everything that we've built? So most of the time I end up talking about engineering populations of wild organisms. So we came up with a way to use CRISPR, the genome editing tool, to encode it in the cells of organisms in such a way that the alteration that goes along with it will always be inherited, because the editing just happens every generation, and so it can spread through a population, which is great if you want to say get rid of malaria or otherwise edit wild species. But what's a little bit disturbing about it is that when I first thought of this back in 2013, no one had ever imagined that that might be possible, that a single researcher might engineer an organism in the lab that could, if released, eventually spread to affect the bulk of a species. So the point is just not everything is actually imagined and portrayed in science fiction before discovery, but most things are. So a book I read quite some time ago, so Heart of the Comet by Brennan Benford, gets into a lot of these questions of what would we engineer humans to be like in the future? And the obvious one, particularly obvious in the context of the last year, is viruses. So if anyone currently listening actually likes viruses, please write it in the chat. There's usually one or two virologists in the audience or just someone who kind of likes the idea. But frankly, most people really aren't fans. And in science fiction, including this book, there's a common trope that future humans will be engineered to be resistant to viruses, or at least when they catch a cold, they don't get the drippy nose and the sneezes and the coughs and all of the miserable symptoms anymore, because those responses are snipped out. At least that's how it's described in Heart of the Comet. But what my group is interested in is what can we use with CRISPR? Can we use CRISPR, which is really a bacterial immune system, against bacterial viruses, among other parasitic DNA elements? Can we repurpose that in mammals? So CRISPR is a system for recognizing snippets of viral DNA. So if you imagine all these are viral DNAs, if we can then design instructions to target CRISPR to each of these. So these are Cas12 guide RNAs that direct the Cas12 CRISPR system to each of the targets. So Cas12 binds each of these, then it takes this single guide RNA molecule and it separates it out into the different elements that target each of these three. And then the Cas12 enzyme uses them to find its target anywhere in the relevant cell, and then it can be cut. So this is how bacteria defend themselves against viruses. But as the commenter pointed out, there's an awful lot of viruses in the world. In fact, estimates range for just in mammals, somewhere between 40,000 and 3.2 million, is the range of the estimates. So the notion that we're going to predict which one is going to cause a pandemic next seems a little bit foolhardy. But that's not really the point. There aren't that many of them in humans. And the difference between a natural CRISPR system, which acquires a fragment of a virus to recognize it one at a time, and what we can do with engineering is we can program CRISPR systems to target many sites in a virus at once, which makes it much harder for it to evolve resistance. The problem is, in order to do this, we need to be able to target CRISPR to hundreds of different viral sequences. And the recognition signals that Cas12 uses to find its guide RNAs is just too repetitive if you try to stack up several dozen of them in a series. So what we did recently is we ran a bunch of experiments to analyze this scaffold. We made lots of mutant variants and we checked to see, could they still direct Cas12 to bind a corresponding DNA sequence? And could they still mediate that processing step of separating out the long instruction set into each individual target sequence? And we found hundreds of variants that appear to be active. And so we can stitch these together into so far dozens, and we believe hopefully hundreds of different targeting instructions for Cas12. And initially, of course, we're going to try this in mice because we try everything in mice first, in mammals. Programming the mice to be immune to entire families of mouse viruses that we know about. All of the mouse parvoviruses, for example, all of the mouse pox viruses, we want to engineer them to be completely immune to. Maybe it will work, maybe it won't. But if so, this is the sort of thing that we could plausibly, eventually, engineer into people to provide programmable virus resistance. But in order to do that, we either need to engineer it into future people or find some way of editing enough of the cells of each one of us listening today. And the challenge is we need to get it into most of our cells. And that's hard because evolution has worked for quite a long time to make us resistant to infection by external parasitic DNAs, that is viruses. So when we try to get DNA into a cell to say encode it to be virus resistant, the immune system fights us. So I think what we need to work on is ways of engineering our cells to be engineerable. putting on DNA transporters in each of our cells that will recognize a particular unique molecular signature on an incoming DNA packet that then will be internalized and imported into the nucleus and stitched into the genome reliably. But we need to engineer the lock so that the key is something that can only be accessed through synthetic chemistry and not through biology. And that's because whatever we can program viruses, whatever we can program to resist current viruses can be evaded by designing the viruses. But now to this question of future people for whom it's much, much, much easier. We don't necessarily just want to put in virus resistance, which would be one packet of DNA, albeit a reasonably large one, but still one insertion. Should we do that? That's a very complex ethical question, but I would submit that I would be annoyed if my parents could have done that for me and didn't, because I would be basically the same person, minus the misery of getting infected by nasty viruses periodically. Wouldn't have helped me against SARS-CoV-2, of course, because that wouldn't have been around, but still better something than nothing. But what about more complex traits? That's what most people tend to care about. And I don't want to dive into the really controversial weeds here, but just point out how could one do it? And right now, we have in vitro fertilization to make a number of embryos, and then pre-implantation genetic diagnosis, which lets you grow up the embryos in a dish, pick one cell off, and sequence the whole genome for each of the embryos, and then decide, based on those genome sequences, based on the predicted health profile, which one you want to implant. That's available today. So with that, you can plausibly enhance multigenic traits, things that are impacted by several dozen or hundreds or even thousands of alleles, but you only get a limited selective power because there's only a few embryos. And of course, making multiple embryos is controversial, but most human pregnancies don't make it to term. So I'm going to set aside the question of the moral status of embryos. I personally tend towards a approach of if it can't feel or suffer, then it's not morally relevant yet, but reasonable folks may differ on that front. What people are working on now in mice with hopes of applying to cows is something called iterative embryo selection. And the idea is instead of just making embryos from current sperm and eggs, instead you use sperm and eggs from two parents and combine them in normal IVF, you make embryos, and then you use those embryos, you grab out embryonic stem cells from them, and you culture them in a dish, directing them to differentiate into sperm and eggs. And then, of course, you can sequence those embryonic stem cells first to figure out which genomes they have, and then you know which sperm and eggs to combine, which then, of course, gives you another embryo, or rather a whole lot of embryos, all of which you sequence again, check to see which ones have the alleles you want, differentiate again into sperm and eggs, and then combine, shuffle, repeat. So you're doing whole generations essentially in the petri dish until eventually you get the genome you want, or at least you're satisfied enough with. And then you implant that embryo, or in this case, in the cows, they plan to use cloning. So that's one way. If we can figure out how to do that, that would make it tremendously more powerful and give us control over much of the genome. But the other way is pretty compelling. And this is just the Carlson curve cost chart for DNA sequencing and then oligonucleotide, so short DNA fragment synthesis, and whole gene synthesis. And you'll note that the green line here is whole gene synthesis. And it's currently decreasing at a cost at a rate considerably faster than Moore's law. So one can project ahead and say, in about 20 years, the cost of making a whole human genome from scratch may well be, based on those projections, about the same as it will cost to attend MIT. So you can think about that for your future children, what you would prefer. Give them whatever advantages can be accrued through this kind of engineering, or set aside funds to send them to elite universities someday. You Europeans have it easy. The caveat for both of these methods is that we don't know how to reliably reprogram the marks that control gene expression in cells that say which kind of tissue are you, which kind of cell. And that is why most attempts to clone mammals fail. And it's why Dolly the sheep was pretty unhealthy throughout much of her life and died young. So unless we can work those out, we obviously can't make future humans using either of these methods. And we'll be stuck with current approaches. So it's highly uncertain whether biology will really be able to reshape the genomes of future humans at many, many different sites throughout the genome. In principle, it's possible, but there's a lot of major barriers that remain. Still, supposing that we could do it, even to a limited extent possible today, what are the most important complex traits to optimize? Again, reasonable people may differ, but I submit that they are morality and wisdom. And that's because if humanity is technology, then which technologies we use determine what humanity is like. Not just the future people, but also the way we live our lives today, the way we treat each other, the way we love, the way we laugh, the way we live. And above all else, future humans must respect one another's decisions and avoid unilaterally placing many others at risk. If you want to risk your own existence, that's on you. That's individual freedom. But you should not jeopardize the lives of everyone else. And the problem is technology could plausibly become that powerful. Again, I specialize in engineering evolutionary fitness, including engineering things that, if released in the wild, will spread. And we've seen what happens when you have an invasive exponential biological agent spread through humans lately. We know now that viruses can be more destructive than any nuclear warhead. And COVID-19 was not a particularly nasty pandemic on the scale of historical pandemics. It's been a horrific tragedy and source of loss for far too many. We could have done far more against it than we did. We made lots of mistakes. But our ancestors had it much, much, much worse. And even more, today, thousands of people can build a virus from scratch if they know what the genome sequence is. Which leads me to wonder how we're going to manage in a world where not nuclear proliferation, but pandemic proliferation is a thing. Because there's too many of my colleagues who think that you can predict what the next natural pandemic will be. And they're brilliant, well-meaning people, but they don't think about misuse. They haven't thought that if you identify a virus that you think will cause a pandemic if introduced into humans, you've just given every researcher with the ability to assemble that virus and boot it up from synthetic DNA, the ability to ignite a new pandemic. That's just one example of bio. I am similarly more scared of things that can replicate exponentially than I am of most other technological threats. But it is why we need to focus on differential technology development. If we want to see humanity continue on our current trajectory of improvement, of lifting people out of poverty and suffering and anguish, giving them control over who they are and who they want to be, all of that is at risk if we discover the wrong technology that is sufficiently powerful, destructive, and accessible. So we need to learn to recognize when we're not ready to handle an advance, and if necessary, to tie our own hands. And so this is something that we're working on through a number of projects in which we hope to crowdsource threat identification. So anyone might have an idea of something that it would be horrifically destructive, but we don't want to share that information because not all of humanity is yet trustworthy. So what we need to do is crowdsource threat identification and build a computational system to limit access to the relevant synthetic DNA without disclosing what any of those threats are to anyone other than the people who thought of them. So that's the premise of one of the projects we're working on. And I hope it will be a template for what we might achieve in other domains of technology that might not be so simply encoded as biology is in DNA. That's all I've got. Looking forward to the discussion. Thank you.
Yeah, thank you, Kevin. That was kind of mind blowing. We have some questions from the chat. The first from Gennady Stelerov. He is asking, what is your assessment of the relative ability of humans today to engineer more dangerous viruses versus engineering effective defense against viruses? Which set of capabilities is more advanced?
I think we are far better at engineering viruses than we are making defenses against them. And I think that's just been demonstrated by the most recent pandemic, because SARS-CoV-2, whatever its origin, was not intended to be a weapon. There's just no way. Anyone good enough to make it could have made something much worse. And what that means is that we're highly vulnerable to accidents. And as anyone in cybersecurity will tell you, any system vulnerable to accidents is fairly helpless against deliberate attack. Right now, we don't yet know how to reliably attack. We don't know which sequences will correspond to vast destruction. So my position is, let's not find out until we've got better defenses.
Fair enough. Fair enough. Thank you. We have another question from Robin Nagel. He's asking, besides making people immune to entire families of viruses, what more would be possible with the techniques you're using / applying?
Yeah, so I think of biotechnology right now as being driven by advances on 4 pillars. So one is PCR, making lots of copies of a nucleic acid, and that's what we use for our COVID tests. There's DNA sequencing, just reading off the code, DNA synthesis, making the code writing to whatever we want, and CRISPR for editing the code of what's already there. So any advances using CRISPR they unite the 3 major classes of information encoding biomolecules. That is DNA, RNA, and proteins. CRISPR is a protein that uses an RNA to find a corresponding DNA sequence. And so it's sort of the ultimate multi-purpose Swiss Army knife in biology. If you can get a CRISPR system into a cell and program it to, say, interact with other proteins and bring them to a particular DNA sequence, you can turn genes on, you can turn genes off, you can mess with the epigenetic state, you can label it so you can see it, you can direct things to different biological compartments. It's just a tremendously useful tool for all manner of engineering biology. So a lot of our work on multiplexing, just being able to target lots of things at once, would facilitate all manner of research. So the biggest application of CRISPR is has nothing to do with the clinic or even engineering animals or agriculture or wild species, editing mosquitoes to get rid of malaria. It's actually accelerating biotech in the lab. It's making all of the other advances happen faster.
Yeah, thank you. So we are kind of running out of time, so we will continue this discussion during the panel. And for now, let's have another break. Thank you very much, Kevin. We'll see you in about 15 minutes again. So now we can go back to the teamhard.nl/break and maybe answer some questions together again. And again, don't forget about the bingo cards you can fill in. All the speakers are also, of course, invited to participate in our activities. And also don't forget about the networking rooms that we have. So yeah, let's find out what aspects of transhumanism interests you the most. So far, engineering is leading, but by not much.
There should be ample food for thought after all these presentations for this.
Yeah. So this break is actually mostly focused on questions about transhumanism. Interesting to see what you all think about this field after hearing all the presentations. But which one would you choose, Victor?
Yeah, I mean, for me, that's kind of obvious. It has to be engineering because that's basically what we're doing.
Pretty much.
But maybe if I weren't an engineer, I would like the societal part about this the most. Yeah.
And how about biological?
Ooh, that is like, I'm obviously not a biologist. I have no idea how everything works, but the concept behind CRISPR and stuff sounds amazing.
Yeah,
it would just
I
be
can't
so
argue
cool.
with that. But look, societal has kind of overthrown the engineering.
Yeah. People are stealing my alternative hobby.
Well, too bad. There is no industry for you to switch to.
Right, let's see what's next.
But okay, if there was an app store for senses, what sense would you download first? Yeah, they're kind of relating back to what we actually do. For those who didn't hear, we're kind of creating an app store for your body where you can download new senses. So it's interesting to see which one you would download first. So maybe we can pick a new direction for our application.
I mean, I would know it, but what would you choose?
Yeah. Oh, people would choose internal health.
Yeah, that's a very popular one.
I think I would also go for internal health.
I'm just a sucker for 360-degree vision.
Yeah,
I
you'll
can't
love
deny it. Yeah.
I just think that internal health would be more useful, at least immediately. It's also very nice to like feel how you process certain kinds of foods, what kinds of workouts work best for you. You'd be interested in that.
Yeah,
You love
probably,
working out.
probably. You can feel the internal protein levels.
Yeah.
That would be perfect.
You can count them, but what if you don't have to?
Yeah, that would be amazing.
Yeah.
All right, so this is, well, this is a clear result.
Yeah.
This is very clear.
Your opinion is
We
no.
know what to do.
Yeah. Okay, let's go to the next question. Yeah, what kind of enhancement would you like to create for yourself? So besides senses, so there is cognitive, so maybe enhance your brain, or physical, maybe think of exoskeletons, medical, maybe pharmaceuticals, or like treating diseases, and lifestyle. You can think mostly like what we also do today, like coffee maybe, or exercising. Yeah. And biotech, yes, Kevin was talking about CRISPR technologies, like gene modification.
That would be insane.
Yeah. I probably would, if I had to choose what to do first, I would want to do all of them actually. I would go for cognitive.
Wow, but that's because the exams are close.
Yeah, the exams are really close. Or also, it's very nice to learn different things, right? So if you don't have to spend that much time, for example, learning things, it might be quite interesting.
That could be cool.
Yeah. Then probably medical or biotech.
Oh, the biotech one would be the scariest one, but potentially also the coolest one, I guess.
Yeah, for sure. Only 2 people apparently would choose.
Well, we can
biotech.
start a club. Contact me, please.
Yeah, we can. Okay, let's go next. So, are you more excited or scared of the transhuman future?
What about you?
I am more excited.
Yeah, it's hard not to be.
Hard. Yeah. What about you?
Well, it is a bit scary, but yeah, I can't help but be much more excited than scared.
Yeah. I'm of course also scared, but I'm mostly scared not about the technologies themselves, but about the misuse of them. Because most of the technology being developed by scientists with good intentions, and until somebody comes along and uses it, and we don't have enough regulations for a lot of technologies developed these days, like artificial intelligence.
Yeah, and there will also be stuff with access to the technologies. I guess we can talk about that in a minute.
Absolutely.
That's gonna be weird, especially in the beginning.
Yeah. So, but still, most of the people are excited, so that's good.
Then we did something right tonight.
Okay, so I think this is the last question. So, how far do you think we are already in becoming the post-human race? So, post-human is the person who kind of finished their evolution. So, we are now transhumans because we are still in an intermediate stage in our evolution. But maybe you believe that we are not going to evolve anymore. But so far, nobody thinks that.
What do you do? You think we'll ever reach 100%? Is it even possible?
Probably not.
Yeah, right.
Yeah.
There will always be more to do, I guess.
It's probably a question of what makes us human. I think there's a lot of debate around this
Well, that's a fair
question.
point. Yeah.
Yes, but just according to you, at what point will we stop being human? And this is maybe will be the end of our evolution. So,
Well,
yeah,
but apparently we have a lot of work to do,
yeah, for
right?
sure.
According to most people. So that's nice because that means we have stuff to do with the team.
Yeah, we are not out of job. Yeah, that's definitely good. But yeah, okay. Then you should enjoy the rest of your break. Go do other activities like bingo. Go socialize with other attendees and with our members in the networking rooms. Every link can be found in the YouTube description. And we will see you at 9:15.
See ya.
See ya. Hello. So we are back from the break for the panel discussion. We prepared two topics to discuss, but we want to involve the audience as much as possible with this discussion and maybe have it all together. As we mentioned before, this is our first event, so we don't have experience in how it goes, frankly. And we'll see how it goes. So
Great seeing
all
all
the
these
speakers,
faces.
yes, are popping up on the screen. Okay, so we've also noticed that during the break there's been discussion on YouTube, and I see that Anders has been an active participant there. Do you maybe want to update us on what's been going on?
Well, there was this interesting question about does autism have a place in transhumanism? And besides, of course, the generally inclusive nature, I think, of a movement, there is something very important about having cognitive diversity. We need emotional, embodied, and cognitive diversity because we need different ways of thinking about things and solving problems. And then somebody brought up another important thing. Yeah, but sometimes maybe you can get bad, weird ideas. And I think the really interesting thing is, historically so far, the really atrociously bad ideas humanity has got are usually amplified, fairly standard human ideas. They're not the unthinkably weird ideas, but rather the all too human ideas. But there is a real challenge in a world where we can manipulate each other using digital information or optogenetics or normal genetics or any other means. How do we maintain integrity? That might be a design thing we might want to work rather hard on. And it's both kind of a hardware technical problem. It might be the social software technical problem we need to pursue.
I think this debate about integrity is something that Kevin Esvelt is also focusing a lot on, if I understand correctly. So I'm curious to what your view on that is.
So I think overall, this is one where I agree with Anders. I think we differ most on our optimism pessimism, because I happen to be in what is probably the most offense dominant field of destructive technology, and so I'm probably a little more pessimistic than is warranted for technology as a whole. But in terms of the potential bright future, I generally agree that there is a lot that we can and should explore that is profoundly good. Mm-hmm. And the way that we get there is being respectful of how little we actually know. I mean, the human moral space is probably so impoverished compared to all the possible moral systems one could imagine. Why on earth would you assume that anyone has got it right? I mean, after all, we generally condemn most past generations for getting one or another thing horrifically wrong. Do you suddenly think that we've all figured it all out? Like, that's pretty profoundly arrogant. So I prefer to acknowledge that, I mean, look, even in mathematics, you can't have consistency and completeness at the same time in the same formal system. What makes you think morality is any different? So I would advocate, let's be a little bit less arrogant about this. Let's be humble enough to say we don't actually know what is right. So some people have called for a long reflection, that we need to first sort out how to not blow ourselves up or otherwise have problems like that. And then just sit around and think and let people explore different ways of being and decide what we should do. What are our responsibilities to one another, to the many other living things that we share this world with, to our ideas morally relevant? Like, they're replicating informational patterns just like sequences of DNA. What is relevant about us? Are we our biology, or are we our ideas? We need to figure all of this out before we make rash decisions. But at the same time, it's plausible that we might actually want to not put all our eggs in one basket. Yeah. So there's a tension between these ideas, but I am very much in favor of exploring more modes of thought than we have currently dared to dream of, because as we know, there's always more of which to dream.
Yeah, of course.
I will probably never stop dreaming either.
Yeah, and about dreaming, there is an interesting question in the chat. So what if superhumans get more intelligent than its creators? Would they take over and create superhumans? And where would it stop? Peter, what do you think about it?
Well, this is, of course, part of a discussion we have in AI safety. The traditional worry was, well, if you get a sufficiently smart machine that can do things that humans can do, one of the things humans have been able to do is making smarter machines, so it might make smarter and smarter machines, and then it takes off arbitrarily far. And I think to some extent this is, of course, what has already happened. Those monkeys I was joking about in my talk, they in some sense created super monkeys. And we, the super monkeys, are making ourselves super monkeys. And it's moving on much faster than evolution would normally do. Now, the real question is, where does it stop? There's both a rate limit. You can only modify genes so much, even though iterated embryo selection takes that up to 11. But having ideas spread around is also super powerful. That also accelerates things. And it might very well be that when we add a bit of artificial intelligence and other things, that speeds things up more. I think there are physical limits. In some sense, there are very boring limits on how fast quantum states can flip and how much mass and energy you can use to do computation. But that doesn't actually tell us anything meaningful about where it stops. I don't think we have a good idea where it stops.
And now I see that Ed Boyden is back. So welcome. We will just start.
Hello, everybody. Good to see you all.
Good to see you too. So there is an interesting point from Gennady Stelerov in the chat, Victor.
Yeah, the problem with a long reflection, as was mentioned before, is that we would age and die while engaging in it. And we need to radically push forward to reverse senescence now, so we have all the time in the world to reflect later. I guess this perfectly describes the opposing point of view. I'm wondering, actually, maybe from the point of view of Peter, Joosten, what do you think about these two contrasting views?
Yeah, it's an interesting point, also a political one. If I recall, if I have the name correct of the commenter, So and that's also what makes me think, because I think the general consensus among the speakers is about the reflection time. But yeah, you can also indeed argue that there are some issues we have to deal with as human species right now. Think of, for one, the climate crisis, but also the growing inequality. That there are indeed also, yeah, you can also make the argument that we need action on that now. And I'm not sure if it has to do with transhumanism, because I think in a sense the word transhumanism is a little bit misleading, because transhumanism is always something that seems to be in the future, while for people in the 1950s, when they are time traveling till our current day and age, they think they are envisioning a transhumanist world, maybe. So maybe also the goalpost is moving ahead. So yeah, I'm also curious about, for example, Yoeri's take, because you also mentioned the multidisciplinary action. Yeah, what do you think of that question?
So if I correctly understand it, it's about whether transhumanism is something that we want to envision or go into now and make ourselves better, or whether we really want to reflect a little bit first before doing that. Well, I guess it depends on the situation, and I also have the feeling this was a similar debate when AI was actually getting more and more important. So you have these AI networks that can very easily find cancer on photos of MRI scans or CT scans, and at that point it's really helpful for a lot of people. But then if you use those similar networks to actually make a decision whether a gun is autonomously shooting humans, then it's the other. So I think while you're doing it, you have to have these discussions like we're doing now, actually, and to have philosophers and people thinking about the implications, and even maybe put some people that have some power to actually decide whether things can go through or not. But I think it's not I'm not an expert on these things, but I think it's better to try things for the greater good than just to wait and see whether it's actually worth it in the end.
It's interesting you mention people who have power, but who should be those people who have power to decide such important things? Should it be scientists who understand the technology, or some government people? Who should?
Yeah, I don't know. Ideally, it would be a government advised by people in the fields, I guess. So we scientists, we don't like to have power usually. So.
Yeah, what I, if I can intervene, what I really liked was to make a little bit of marketing for the series on Netflix, in which also Kevin Esvelt was featured, Unnatural Selection. And one of the episodes, what I really liked, is where you were visiting a city council, if I remember, on an island to talk about gene drive of rats or mice. I don't remember, but that really made me think about the question Mariia just asked, like who should decide about it? Should we leave all the voting powers to Anders and his fellow philosophers, or
oh no,
or should it be general public? But I'm just curious also on the opinion of other speakers, because as a base point, I would say it should be a democratic initiative where everybody should be involved, and not only the current politicians, at least in the Netherlands and the EU. They're also they are focused on the four-year term to be re-elected. It's really difficult to get the dilemmas of, as you also can see with the pandemic, but especially also biotechnology, germline modification, to have a debate about it among policymakers. So I'm curious, what would be the governing ethical decision board or debate on this issue?
So it's quite easy to think that it's the government's job to do it all, but a lot of the ways we're interacting and deciding what we can and cannot do is set by other factors too. After all, the big internet platforms to some extent limit on what you can say and do online. Politeness and what your friends and family will say also control a fair bit of what we do. We have various forms of control, and similarly, we exert various forms of power. So quite often we say it should be a democratically decided decision, but usually that doesn't mean that we have everybody vote for something, because quite often that produces very stupid results. Ideally, you want to have a bunch of representatives we mostly agree represent our views and are mostly sane, and they can hash it out because we have better things to do in our lives than deciding tax rates. So there are various tools and mechanisms. And I think it's worth recognizing that this is also a form of technology. About 300 years ago, the printing press started to increase the ability to process and move information around in society. And people started innovating various pieces of the governance technologies. Over in Venice, for example, we had these very complicated systems of elections and selection for committees that would be very hard to game. Now, others invented various forms of parliaments and ways of running political parties. And gradually, we have taken the best of these systems and patched them together into governance systems. It's just that recently we had another printing press. We got so much more powerful tools, and we still haven't figured out much of the technology in this bigger governance space. So this is, again, something where I think people interested in the social and political side of transhumanism have a lot of important work to do. We need to kind of aggregate preferences and come up with compromises that allow us to make sometimes very, very important or even harsh decisions in a way that most people say, yeah, that's legitimate. I hate it, but I have to live with it.
I think that's a very fun point, because in making those types of decisions, like obviously we as humans like to be as rational as possible, or at least think we are, but often there's also an emotional component in there. And there's a very interesting question about that in the chat from Adrian. Yeah, could you pull it up? Yeah. Thank you. Which is a question for Ed Boyden. Let's say we look at this emotional aspect. Could we actually simulate emotions within the brain, maybe? And how useful would that be? And isn't there a second part to that equation besides the brain, which is the different level of hormones within the body?
I guess it depends on what the definition of the word useful is for the first part. And I think there's at least two kinds of use. One is to understand what an emotion is. And the other, of course, is that many disabilities like untreatable depression or anxiety disorders and so forth cause a lot of suffering. My hope is that the simulation could be quite useful for both. You know, if we can see what the nuances of how a neural circuit implements an emotion occurs, maybe it would help with both understanding and with repair. We're on the second part of the equation. Absolutely. Hormones, excuse me, but also going beyond hormones, you know, the microbiome in the gut, influences of all sorts of things, the immune system, everything interfaces to each other. So when we talk about the brain, I think that's shorthand for the brain and everything that connects to it, right? Because you can't just treat a system in isolation without considering all of its influences. And so one of the key things I think that is going to emerge is the need to be able to map across not just the brain, but the body. And a lot of exciting neurotechnology that's occurring right now from groups like, Polina Anakeva's group at MIT, for example, and others, is to look at the distribution of neural signals throughout the body and how they can influence the brain. And there are so many remaining to be discovered.
Yeah, and maybe those types of interfaces with the body to check these types of things, is that also something that Yoeri could focus on in the future?
Certainly, this is definitely something that we're very interested in. So I always like to imagine a prosthetic arm, as I said, that depends on the certain neurotransmitter that is emitted. So if you have adrenaline, then it actually should move faster than, for instance, if you have a lot of dopamine, you're more happy, then you want to be a little bit slower, for instance. So using those signals directly for enhancing prosthetics for people without arms, or even, I mean, we're in a transhumanist panel, so even people who want to have just better arms, I guess that's why not? I mean, that's a nice idea, yeah.
Yeah, nice. There is also an interesting question in the chat close to the topic from Cameron. How do the panelists, so all of you, conceptualize the implications of altered states of consciousness on the transhuman race? If we cannot simulate these experiences through technology, can we create consciousness at all?
Well, there is, of course, that classical philosophical question. Well, would a software replica of my mind have my experiences? And there is one gang of philosophers who happily say, oh, yes, it's performing the same function. That's going to be your having your consciousness. And then you get another gang saying, no, no way, no way. And then, of course, you get a whole group set of other philosophers having more complicated views. We don't know. I think the best approach would be to take kind of Searle, leader of one of the gangs, saying that computers can't be conscious. And if we make a software Searle, and software Searle says, darn, I was wrong, I need to write a paper, then we have learned something. But that might be rather far away. In general, of course, what consciousness is a darn hard problem, not just for philosophers, but also for neuroscientists and psychologists. And we certainly have tools that affect consciousness in the form of drugs, or for that matter, various forms of stimulation of the brain. I think if brains become more accessible, I think we're going to learn a lot more about consciousness. But it's tricky because you need to have a functioning brain that can report back. And it's so much easier to work on fixated brains in a block of plastic.
Mm-hmm. This sounds like something Ed Boyden would also have an opinion about. So I'm actually very curious on that.
Well, we don't yet have a consciousness meter, right? You can't plug something into your laptop and point it at somebody and say, you're conscious. In fact, you don't know for sure if I'm conscious, right? Maybe I'm just a very accurate robot, and the real Ed Boyden is off on a beach somewhere enjoying a lovely day, sipping a daiquiri and enjoying the waves. And so that's kind of one of the biggest problems as a scientist that I think we do face in neuroscience. And consciousness is an internal state, and it's subjective, and there's not an obvious way to measure it currently. And that's something that I think we have to invent a new strategy for. But of course, it's very difficult to see that path with existing science. And that's one reason why I hope the tools that we build can pave a way to thinking more about it.
Yeah.
That makes sense.
To a little bit change the topic, there is a question to us actually in the chat. It asks, why is there no transhumanist group organization in the Netherlands?
Mm-hmm.
Well, we are a transhumanist group in the Netherlands. We are HART, which stands for Human Augmentation Research and Technology. So yes, we develop the technologies, but one of our main pillars is raising awareness about human augmentation and doing this kinds of
events. I think basically our team started with this general question: why doesn't something like this exist? So yeah, get in contact with us on this. We are of course looking to expand there.
So may I interject here that there was at least a Dutch transhumanist group, Transcedo. So this was back in the Stone Age, back in the 90s, long before there wasn't blogs. We were communicating by something called mailing lists, done probably by banging stones together. But back in 1998, they actually organized the first World Transhumanist Association meeting, Transvision, in Weesp outside Amsterdam. So that it existed. So you're kind of inheriting the mantle now.
That would be great.
Yeah.
So I've noticed there's been a lot of talk about aging and people pushing back on the long reflection based on we shouldn't let people age and die. I totally agree. The long reflection only happens once we're safe from existential risk and suffering and death. The challenge is going to come, what about when we look really hard at, say, children suffering? And then we're going to have fierce arguments between folks who say this is unacceptable. We are allowing innocence to suffer. We must rewrite the nature of humanity to prevent innocence from suffering, versus those who say, whoa, 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 we're in a long reflection here. And so saying, where do you draw the line? But I think we can all agree that we need to solve existential risk and senescence and death. Now, the challenge, I think, there's a lot of promising senolytics research and so forth. But from a biological perspective, the probably the most reliable way forwards for restoring youth and health is really only suitable for cartoonish villains, even if it's ethically okay. And that is something along the lines of take some of your cells, reprogram them to make induced pluripotent stem cells, then basically do the beginnings of cloning yourself. But first, edit your cells so that you can't actually develop much of a prefrontal cortex that would be functional. And Ed would know much more about exactly which genes would do this for which disorders. But so you just couldn't become a person at all in the resulting being. Then actually do the IPS transformation and implant into an artificial womb. So you got to develop those too. And then grow up this baby, which would, there wouldn't be anybody home. And then grow it up until it's, 12 or so, and then do a head transplant. Yeah. So ethically, there's not a person there. There's not even as much as a mouse. Like a mouse would have more personhood. You could argue, probably maybe not a worm, but a fly certainly would have more personhood than this being. It would be your body with no brain, basically, or as close to it as you can get. So from most ethical perspectives, and I would defer to Anders here, of course, this looks plausibly okay, but the optics are about as bad as you can imagine. Like, talk about cartoonish supervillain way to path to immortality, grow up your own, cripple the brain development of your own clone and then lop off their head and stitch yours on in its place. That's pretty awful. But right now, it looks like the most plausible. So if anyone in the audience wants to go for that and figure out how to do the much harsher problem of rehabilitating the image, by all means.
So I think the interesting thing is this shows that there might be some pathways to certain ends that we might say, yeah, it could work, but no, it's too yucky. And in some cases, it might be that, yeah, ethically, we're not allowed to do it. But it might also be that, yeah, some methods are actually just too plain disgusting. There are actually a lot of cultural choices in what technologies we get. So when you think about life extension, I think most of us would prefer it to be a little pill. Maybe injections of stem cell. If we had to do parabiosis, exchange blood with younger organisms, that's already in cartoon villain territory, even if we did this in a relatively ethical way. And this, of course, goes for quite a lot of other technologies too. It's not just that we select what works most efficiently. Even in areas like big business or the military, quite a lot of technologies have not been chosen because they're the most effective. But do they fit with our cultural values? And being clear about these values, I think, is super useful. So the long reflection, I think one can always start a bit early with that, just thinking about how do we think about our place in nature and the universe? Because that's quite often the source of a lot of arguments about transhumanism. A lot of critics have a particular view of what's natural and how we're supposed to fit into that natural order. And then others show up and they don't share that view and just say, we could do this and this would be great. But it's against their unstated assumption about what the natural order is. But of course, since we rarely bring up what we think the natural order is, because that sounds a bit silly, people instead bring up, well, what about safety? What about inequality? What about life extension making dictators live forever? And even when you knock over the arguments, for example, the dictator argument is very fun. I've been doing the statistics on that it only gives 4 more years. They, of course, the critic will immediately bring up another one, because the real thing is, yeah, it doesn't fit with the natural order they envision. And I think we should be more open, discussing what kinds of natural or unnatural orders we accept and find reasonable. That's both good for openness and also for getting really interesting conversations late in the evening over a glass of wine. But I think it also actually helps dealing with a lot of the critics.
But do you also think, because that's something that comes up with me while I'm listening to the discussion, like if we have more healthy years, then we have more time for reflection and think about the natural order. But would at the same time, the majority, like 90% of society, will spend the more time they have on Instagram and Netflix?
Yeah, but if they get happy from that, and hopefully we can find something that makes people fulfilled and happy, and not just this like chewing gum for the soul, then that's fine. After all, very few people have ever wanted to actually be philosophers or scientists or engineers. it takes a particularly kind of weird mind to think that that's a good thing to do. Most people are fairly happy to be couch potatoes, and we might want to help them to be the best couch potatoes they could ever be. Because and if we want after a while to actually, it seems like the scientists are having all the fun. We should help them become the scientists.
I like actually, Peter, how you say that at some point 90% of people will have extended lives, because that's topic I find really interesting, and I think somebody already mentioned it in his talk at some point. All these technologies, right? If you want to grow a fully new body up until it's 12 years old without being conscious, I imagine they will be crazy expensive. So only available to a very small part of the population, especially in the beginning stages. And this could lead to a traumatic, changes in access or differences in access to these technologies. Is there any way that we could prevent that at all? Or is that just an inevitable thing of this development? I'm curious as to what your opinion is on this.
I think just like in the line of arguments that Anders just shared, is that indeed one of the one that is mentioned the most. I think also in your polling you did in the second break that the societal impact concerns people the most, also with ethical, which are of course closely related. So I'm not sure, because on the one hand, there are people, advocates that say, take for example CRISPR, it's way more, it's way cheaper than previous similar technologies. But on the other hand, I cannot afford with the lab equipment and also the specialized knowledge to do the supervillain experiment by Kevin Esvelt on myself. So just to take that as a running gag, I hope you don't mind. So and I think that would also be like more a political choice, and also be like for whom is this technology available. Maybe we get into like not only a base income in the future, but also like a sort of welfare state in which we in Europe can envision even more because of our current situation compared to the US, where you maybe instead of only being helped with certain diseases, you can also get access to certain upgrades in the future just to get a level playing field. But these are all like system change, and also maybe change our idea of what is our current human nature. So I think there's also in that domain there's a lot of work ahead.
There is also an aspect of what kind of technology it is. So this is actually something Ramesh Nan, another fellow transhumanist and science fiction writer, mentioned to me offhandedly many years ago at a break and a conference. It stayed with me for a long time. And that is gadgets like smartphones and pills. They come down in price exponentially, especially once the patents run out, because you can mass produce them and they just become cheaper and cheaper and cheaper. Services, on the other hand, tend to stay pretty expensive because you need to pay the nurses and doctors maintaining your evil genius lair. Those minions, they want a salary. And that means, of course, that any enhancements that you can package as a pill or as a gadget can relatively quickly become everybody's. Anything that has to be a service will tend to be expensive. Sometimes we decide, okay, this is expensive, but it's so good we need to give it to everybody, like healthcare, like education. We might even make some enhancements mandatory, like education. So the choice we have here as researchers and technologists and visionaries is to try to figure out ways of packaging things so at least the more safer ones can become these exponentially cheaper ones. This is incidentally why I'm kind of admiring the tool makers among you. I mean, Ed, Kevin, and Yoeri, you have made tools that enable us to do the first steps in making the things that can then come down exponentially. I think the sad thing in science is that we typically tend to award somebody who figured something out, but usually didn't make anything useful. But if you invent a tool, that's usually how you create entire burst of science, which we're kind of seeing right now with the brain, with the neural implants, with gene drives. So first you need to get that burst, then package it into the gadget. And then I think inequality is going to become a relatively small problem.
Well, I'd just like to note that the consequence of that is vast cities full of factories with spare bodies slowly being grown in pods, because you ship everyone their little kit in the mail, and they swipe their cheek, and then they put it back in, and then they send it back to the factory, which automated does all the cellular reprogramming and begins growing it, and has the tanks of artificial wombs and all the maintenance for the bodies and so forth. And sure, that doesn't require any doctors or nurses or service. You can give the evil overlord plan for immortality to everyone. But it would be much better if we could just print those bodies using a 3D printer to begin with, and I think everyone would be much happier with that.
Yeah.
Even if on a molecular scale the results are identical, you have to think about whether people are interested. Because look, if you invent an immortality serum and people aren't willing to take it, on some level you are morally responsible for failing to save all those people from death.
And of course, even if you could 3D print a new, better body for people, there are always going to be some saying, I want a free-range organic body.
Yes, but you have to take that into account, right? People can believe what they want to believe, and you have to do the best you possibly can for them regardless.
Yeah.
So this is why our mantra is always, when going to communities for eco-technologies, it's different. Medicine, your doctor recommends that you can say no. But you're proposing to change the environment, that's going to affect everybody. Even if they vote on it, they get outvoted, it's getting jammed down their throats. They're going to be affected no matter what. So the key is not so much governance. Do you want to use it or not? It's giving people a voice in the early stages of technology development, because that's what will determine the eventual scope of the application, the flavor of the application, as well as the risk-benefit profile in terms of tuning it within the parameters of what is technically possible. If you just invent it all on your own based on what you think people want, then you're very probably going to be wrong. They're less likely to accept it, and then you'll have wasted all of your time. Whereas instead, our role is, it's your environment, it's your call.
Yeah, I think that that's also a big theme in at least what we experience as a student on TUE, that this is involving end users in the beginning stages, thinking about who's actually going to use this technology is very much incorporated in education. So I'm actually curious to Yoeri, if that's also a focus point in the research that you are doing yourself.
Yoeri?
Yes, yeah, sorry, I was muted still. Yes, certainly. So we always go from two sides. One is the fundamental, the interesting part of the materials, how to modify them, how to optimize them. But we always have an end goal in mind. So it can be a smart biosensor that we can retrain with these materials. It can be brain implants that we're currently thinking about connecting with these types of cells. So it's always about some kind of nice application that you can envision in the future. But I agree with the other speakers that it's not something that, I mean, it's very difficult to predict the future. So what would actually be useful, that's not up to us, of course. So for me, it's more interesting to work fundamentally on providing tools and providing new systems that people can actually, sometimes people come to me, oh, can we use your materials also for this type of device or application? And this is actually what you want, of course. So to open up a new types of application field using your technology, your materials, instead of you dictating the public that they have to use this smart biosensor that we are developing. So I think it comes from both ways, yeah.
Of course, yeah. I'm also actually happen to know that at Boyden has his own company that is focused on treating Alzheimer's. And I suppose it's in more of early stages, but I'm curious how you view the accessibility of technology. Do you take this into account?
The accessibility of the technology, yeah. Well, that's one reason why in my little mini lecture, I tried to point out that, there's this old way of thinking about biomedical research, right? There's basic science, often driven by curiosity and serendipity, and then translational work, where the goal is to help a specific patient population. I think technology adds a third leg to the tripod. It doesn't have to be a dichotomy between these two choices. What if the technology can accelerate the basic science so we know what the heck we're doing and reduces the risk of translation? Because currently, of course, for the brain, just as an example, the clinical failure rate is nearly 100% for most therapies, right? I switched from engineering into neuroscience 23 years ago, And during that time, we've had barely any new treatments, much less cures, for any brain condition. So the pathway goes from invention to discovery to design, as I summarized earlier. In the case of the Alzheimer's therapy, Li Wei's group used optogenetics to make the initial discovery that brainwaves could clean up lots of interesting and important amyloid, tau, cognitive, and other features. So that's the discovery. But then when it came to the design phase, and this is where another MIT professor, Emery Brown, made great contributions as well, the teams working together under Li Wei's leadership showed that you could induce the same brainwaves with a movie, right? And so imagine an era where, a flickering light on a display, some kind of auditory device, that's pretty cheap nowadays, right? I mean, there are literally billions of such devices that are routinely discarded as a new, slightly faster, slightly spiffier phone or other device comes online. Accessibility, I think, can emerge from this philosophy. And, a similar philosophy applied to the expansion method, right? So, nanoimaging is a very important area, right? Electron microscopy, super resolution microscopy, multiple Nobel Prizes have been given for those technologies. But then our group decided, let's figure out a way to do that so that you wouldn't require any new equipment. Just take a brain and make it 1,000 times bigger with a really dirt cheap set of chemicals. So anyway, take a step back. I think there's both a strategy for developing technologies, and I like this invent, discover, design way of thinking. But secondly, if deployability is part of your goal from the beginning, then it can be part of every step. You can make your inventions usable by thousands of researchers. You can make the discoveries powerful. You can make the designs accessible.
That is a lot of food for thought. Maybe actually we are nearing the end in the schedule. I'm actually curious if maybe one of the speakers would like to have a closing comment on if the audience would have to take away at least one thing from tonight. What do you think the most important thing would be?
I would actually be interested to hear answer to this question from every one of you.
So let's start with Anders in that case. Go on order as we see him on screen.
So I think my big message is the future is radically open. It's kind of getting defined by our ideas that are fundamentally unpredictable. And if we can just keep the future open, I think we have an opportunity to make it truly grand. So I think that's kind of guiding principle one should be trying to apply.
Thank you.
Thank you. Peter, what do you think?
Yeah, I'm the next in line. Well, I was thinking I want to just give kudos to the organization and also mainly to the fellow speakers, because I think one of the most important things is that we have these technologies, this scientific progress, and at the same time that such remarkable scientists are also willing to share their time and energy to also enlighten us, as myself as just a lay person, on their discoveries. I made a lot of notes, so I think science communication is a big part of our transhuman future. So I think you all done a great job.
Yeah, thank you. Yoeri, it's your turn.
Yeah, so also I fully agree with Peter. Very nice that you organized this. I think this is also one of the take-home messages I guess I have, that there's a lot of things people can do by themselves, but if we really want to go forward, I think it's important to have these types of forums and to talk with each other, being from widely different fields and research fields. I talked about multidisciplinarity being important. You can never be an expert on everything, and if we have these discussions, but also on ethics and the implications on the future and the technology in the future, I think that's very important, and together we can move forward. So yeah, thanks for that.
Yeah, thank you. All right, Kevin.
Yeah, similarly, this has been beautifully run. So thank you for the opportunity in putting this together. And I suppose my parting thoughts would focus pretty heavily on this question of thinking as far ahead as we can, because it's all too easy to be shaped by the day-to-day or even just year-to-year incentives. I mean, for those of us in labs, what can we publish? Okay, what promising things do we need to write in order to get the grant money, in order to pay the salaries, so that when we can do some work and then we have to report on it so that then we can get more money. And that doesn't necessarily lead you to think about your longer term direction. What are we working towards? How are what we are doing going to help as many people as possible? And how are we even certain what help means? So advancing technology needs to somehow be coupled to cultivating wisdom and inviting others with very different perspectives, very different ways of thinking about the world, ways of perceiving the world, with extraordinarily different value systems. I think some of the most profound things I've learned in the last few years were speaking with the Maori of Aotearoa, because they have a profoundly different worldview and just sense of how things are connected than most folk in Massachusetts, especially those around MIT. So exposure to different modes of thought, I think, can help us better understand where we might go. And so for those of us who hope for a flourishing future of expansion in our ways of mind, as well as the length of our lives, I think there is no better way than to combine our thoughts in fora such as this one. So thank you.
So, to summarize, as far as I understand, I can make a reference back to Anders' thought during his presentation. So you should think about the seat belt before you develop in the car, kind of, right? But yeah, okay, thank you. And then finally, what would you say to the take-home message?
Well, I think there's a great desire to improve things, but we need to have understanding so that we can achieve what we want. I think that sort of resonates with the themes that many people have mentioned, whether it's thinking about the future or. But I do sometimes where there's a tension between understanding and getting stuff done. An analogy that I often make is, suppose it's the year 1600 and you want to land on the moon. All the money on Earth won't get you anywhere near the moon because we don't understand gravity, we don't understand calculus. And so suppose you were in charge of funding science in the year 1600. Would you have funded Newton to study F equals ma and gravity, or Leibniz to study calculus, or Newton and Leibniz, depending on which camp you're in? Anyway, math joke. But the point I'm trying to make is, if you really wanted to land on the moon in the year 1600, you would have wanted to go after a lot of deep understandings that would have maybe been counterintuitive. And if you didn't go down that path, all the money on Earth would have resulted in people tying kites to chairs, and they would have all died. So I do think that there's this, need to understand, and we want to translate, and maybe the way to reconcile them is by building tools to accelerate our understanding so that we can translate.
Yeah, thank you.
Yeah, thank you for sharing all your wisdom tonight. I think that goes for us, but also for all the attendees. Normally we would hear a large applause, but we can do this one.
Our whole team applause here. Thank you. But I suppose this concludes our symposium. We just want to show a final thank you slide, if possible. So thank you again to all the speakers for sharing their wisdom and their amazing scientific progressions with us. And we also want to say thank you to our amazing team that you just heard applauding for pulling this off, making the event go as smoothly as possible. And of course, we want to thank our university for making our team exist, basically.
Yeah, big shout out.
Yeah, so we really hope that this is not the last event of this kind that we organize, and we really hope to see you with us again in the future. So you can keep up with us by following us on social media. You can see some links on the slide. So yeah, that's been great. Thank you very much for attending, for speaking, and
It's been
Victor
a great pleasure.
for co-hosting.
Of course.
So we are going to end the live stream now, but we are hoping that we are going to be in contact with all of you again.
Bye-bye.
Bye-bye. Have a good night or afternoon, depending on your time zone.